Hey everyone, welcome to a journey that will change the way you look at the ocean forever. Tonight, we're exploring the most mysterious, haunting, and utterly terrifying secrets that our planet's waters hold. From creatures lurking in trenches, deeper than Mount Everest is tall, to electromagnetic anomalies that make ships and planes vanish without a trace. From ancient underwater structures that shouldn't exist to sound so chilling, they've made hardened scientists question everything they know. The ocean covers over 70% of our planet, yet we've explored less than 5% of it. That means there's a whole world down there waiting in the darkness, filled with enigmas that would make your worst nightmares seem trivial by comparison. So before we dive into these watery depths together, take a moment to like this video and subscribe to join our community of mystery seekers. And drop a comment telling me where you're watching from and what drew you to these ocean mysteries. It's always fascinating to see who's brave enough to explore the unknown with me. Now, let's begin our descent into the ocean's darkest secrets. When you picture the ocean, you might imagine pristine beaches, gentle waves, and colorful fish darting through coral reefs. But tonight, we're going somewhere entirely different. We're venturing to places where sunlight has never penetrated, where pressures are so intense they would crush a human skull like an eggshell, and where creatures exist that evolutionary biology struggles to explain. The ocean isn't just a body of water. It's an entirely alien world existing right here on Earth, teeming with life forms so bizarre they appear to be the product of some cosmic nightmare. It's a realm where fish create their own light in the endless darkness, where colossal battles between giant squids and sperm whales rage unseen by human eyes, and where geographical features shift and transform as if the very seabed is alive. Picture yourself floating alone in the middle of the Pacific Ocean on a moonless night. The water around you is obsidian glass, reflecting nothing but emptiness. But beneath your dangling feet stretches an abyss so profound that parts of it remain completely unmapped by modern technology. And in that darkness, things are moving, things are watching, things are waiting. The ocean doesn't recognize human fears or limitations. It exists according to principles so foreign to our terrestrial minds that our most sophisticated science can only glimpse its true nature. At the deepest points of our oceans, the pressure exceeds 16,000 pounds per square inch, equivalent to having 50 jumbo jets balanced on your body. Yet, astonishingly, life not only persists in these crushing depths, but thrives in ways that defy our understanding of biology. Creatures dwelling in these abyssal environments have never seen the sun, never experienced warmth, and exist in a state of perpetual, frigid darkness that has remained unchanged for millions of years. They've adapted to conditions so extreme they might as well inhabit an entirely different planet. Some generate ghostly bioluminescence, creating constellations of eerie blue-green light in the infinite blackness. Others have evolved transparent bodies, becoming living ghosts drifting through the deep currents, like specters from another dimension. Here's what truly disturbs marine biologists when they study the deep ocean. With every expedition into the abyss, we discover species and phenomena that completely upend our previous understanding of what's possible. Each submersible dive brings back footage of creatures that seem too bizarre to be real, organisms that shouldn't be able to survive yet somehow flourish in the most hostile environment on Earth. And for each discovery we make, a dozen new questions emerge, questions that challenge the very foundations of our scientific knowledge. The ocean has been accumulating secrets since the dawn of time, and it guards them jealously beneath miles of impenetrable water and crushing pressure. But tonight, we're going to peel back that watery veil and examine some of the most disturbing, most inexplicable mysteries lurking in the darkest corners of our world's oceans. Because if you think you understand what's truly frightening, wait until you learn what's been dwelling just offshore all along, hidden in the inky depths beneath the waves. And the most unnerving realization of all? We've barely begun to discover what's really down there. Let's begin our exploration with what might be the most alien environment on our planet, the Challenger deep in the Mariana Trench. Located in the western Pacific Ocean, this chasm plunges to a staggering 36,070 feet below sea level, making it the deepest known point in Earth's oceans. To put this incomprehensible depth into perspective, if you place Mount Everest at the bottom of the Challenger Deep, its peak would still be submerged beneath more than a mile of water. The Mariana Trench isn't merely deep, it's an environment so extreme it borders on the impossible. The pressure at its lowest point is more than 1,000 times what we experience at sea level, enough to compress a human body to the size of a small suitcase. The temperature hovers just above freezing, while the surrounding water exists in near total darkness, creating conditions that have remained virtually unchanged for billions of years. It is, for all practical purposes, a fragment of an alien world embedded within our own. Despite these seemingly impossible conditions, the Mariana Trench hosts an ecosystem of creatures that shouldn't exist according to our early understanding of biology. In 2016, a research expedition captured footage of a ghostly jellyfish undulating through the darkness at a depth of nearly 28,000 feet, deeper than any jellyfish was thought capable of surviving. Its body was almost entirely transparent, with strange internal organs clearly visible through its gelatinous form, pulsing with an otherworldly rhythm. Scientists who viewed the footage nicknamed it the ethereal jellyfish and continue to debate whether it represents a new species or an extreme adaptation of a known one. Some researchers have proposed that it might not be a true jellyfish at all, but something entirely novel to science, an organism that has evolved in isolation for countless millennia in an environment humans have only briefly visited. The Mariana Trench harbors countless other biological anomalies that defy explanation. Consider the barrelly fish, with its transparent, fluid-filled dome containing tubular eyes that can rotate to look directly upward through its own forehead. This bizarre adaptation allows it to detect the silhouettes of potential prey, swimming above it against the faint glow of distant surface light. Imagine evolving to literally see through your own skull, a solution so alien it seems more appropriate for science fiction than reality. Then there's the Mariana snailfish, which thrives at depths exceeding 26,000 feet where the pressure would instantly implode most other creatures. These small pink fish have adapted to these crushing depths through a complex set of biochemical adaptations, including proteins that function differently than any others found on Earth. Their cells contain special osmolytes, pressure-resisting molecules that would cause severe toxicity in surface-dwelling organisms, but allow the snailfish to survive where nothing should. Even more bewildering, when researchers attempted to bring specimens to the surface for study, the dramatic pressure change caused their bodies to literally dissolve. These are creatures so perfectly adapted to their extreme environment that they cannot exist outside it, making them nearly impossible to study through conventional means. Perhaps most disturbing are the hydrothermal vents scattered throughout the trench, creating isolated pockets of volcanic activity on the ocean floor. These vents spew superheated water exceeding 700 degrees Fahrenheit, filled with toxic chemicals and heavy metals that would be instantly lethal to most life forms. Yet around these hellish chimneys thrives an ecosystem of creatures that doesn't rely on sunlight or oxygen to exist. Instead, they've evolved to harness energy from the toxic chemicals themselves, utilizing metabolic pathways completely different from anything seen in surface-dwelling organisms. These chemosynthetic lifeforms represent a completely alternative evolutionary path, a separate genesis occurring in parallel with the more familiar biology of the sunlit world above. The mysteries of the Mariana Trench extend beyond biology into phenomena that challenge our understanding of physics and geology. Deep-sea researchers have recorded unexplained sounds emanating from the trench, low-frequency rumbles, and high-pitched screeches that don't match any known geological process or identified marine species. Some of these acoustic anomalies seem to follow patterns too regular to be random, yet too complex to attribute to simple geological events like underwater landslides or volcanic activity. Even more puzzling, certain sounds appear to respond to the presence of research equipment, changing their pattern or ceasing entirely when hydrophones approach, only to resume once the devices are removed. This seemingly reactive behavior has led some fringe researchers to propose that something intelligent might dwell in these ultimate depths, though mainstream science rightfully remains skeptical of such extraordinary claims. The Mariana Trench also contains geological formations that shouldn't exist according to our current understanding of plate tectonics and underwater geology. Perfectly straight channels cut across the seafloor, extending for miles in impossibly precise lines that look almost artificial in their geometric perfection. Strangely symmetrical mounds rise from the abyssal plain, arranged in patterns that seem too ordered to be the product of random geological forces. Conventional science attributes these unusual formations to previously unknown interactions between extreme pressure, unique mineral compositions, and currents that exist nowhere else on Earth. But the truth is, our understanding of deep ocean geology remains so limited that these explanations amount to little more than educated guesses. What truly makes the Mariana Trench one of the ocean's greatest mysteries is how little we've actually explored it. Despite being the deepest part of the world's oceans, fewer humans have visited the Challenger Deep than have walked on the surface of the moon. James Cameron's historic 2012 solo dive lasted just hours, and even the most advanced unmanned submersibles can only operate there for limited periods before the extreme conditions force them to return to the surface. Our glimpses into this alien world are fleeting at best, leaving endless possibilities for what might still remain undiscovered in its darkest recesses. When we consider that vast sections of the trench remain completely unmapped and unexplored, we must acknowledge a humbling truth. We know more about the surface of Mars than we do about the deepest parts of our own planet. Moving beyond the Mariana Trench, let's explore one of the most enduring maritime enigmas, the phenomenon known as the Bermuda Triangle. This roughly triangular region between Miami, Bermuda, and Puerto Rico has become legendary for the unusual number of ships and aircraft that have disappeared within its boundaries, often under clear weather conditions and with experienced crews at the helm. What transforms this from mere folklore into a legitimate ocean mystery is the documented nature of many of these incidents. Vanishings that occurred not in the distant past of unreliable record-keeping, but in modern times with sophisticated vessels and aircraft. The most famous Bermuda Triangle incident occurred in December 1945, when 5 U.S. Navy TBM Avenger torpedo bombers disappeared during a routine training mission known as Flight 19. The flight consisted of 14 airmen led by experienced instructor Lieutenant Charles Taylor, all of whom vanished without a trace, despite clear weather conditions and multiple functioning radio systems. Even more disturbing, the PBM Mariner flying boat sent to search for them also disappeared with its 13-man crew, bringing the total loss to 27 men and 6 aircraft in a single day. The official Navy investigation concluded with an unprecedented finding. We are not able to even make a good guess as to what happened. The U.S. Cyclops presents another well-documented case that defies conventional explanation. In March 1918, this massive collier disappeared with 309 crew members and passengers while traveling from Barbados to Baltimore. No distress signal was sent, no wreckage ever found, and no storm was reported in the area at the time. It remains the single largest non-combat loss of life in U.S. naval history, yet we have absolutely no idea what happened to this massive vessel. It simply ceased to exist somewhere in the waters of the Bermuda Triangle, vanishing as if it had been plucked from the ocean surface by some colossal hand. In 1963, the SS Marine Sulphur Queen, a 523-foot tanker carrying molten sulfur, disappeared in the Bermuda Triangle with 39 crew members aboard. Despite an extensive search covering thousands of square miles, only a few life jackets and bits of debris were ever recovered. The ship had passed all recent safety inspections, the weather was calm, and no distress call was issued before it vanished. The Coast Guard investigation concluded that something sudden and catastrophic must have occurred, but could not determine what that might have been. What makes these and dozens of other similar incidents in the Bermuda Triangle truly mysterious is not just that vessels disappeared. Ships and planes can sink or crash due to various factors, but the manner in which they vanished. No distress calls, no debris fields, no oil slicks, no bodies recovered, complete disappearances that seem to defy the basic physics of how large objects interact with their environment when they crash or sink. Modern aircraft and ships carry emergency locator beacons, specifically designed to activate and transmit position data during catastrophic events, yet in many Bermuda Triangle incidents, these systems never activated or transmitted any signals. Scientists have proposed numerous explanations for the Bermuda Triangle phenomenon, ranging from the plausible to the fantastic. Some suggest that unique magnetic anomalies in the region interfere with compass readings and navigation equipment. Others point to the possibility of massive methane gas eruptions from the ocean floor that could potentially reduce water density enough to sink ships instantly. Meteorologists have noted that the region is prone to microbursts, powerful downdrafts that can exceed 170 miles per hour and easily force aircraft into the ocean before pilots can react. These theories might explain individual incidents, but they struggle to account for the sheer number and variety of disappearances concentrated in this one region. Perhaps most intriguing are the reports from the small percentage of people who have survived unusual experiences in the Bermuda Triangle. These witnesses describe phenomena like sudden, dense fog appearing out of nowhere in clear weather, instruments going haywire simultaneously, and unexplained light phenomena both above and below the water's surface. Bruce Gernon, a pilot who survived a bizarre flight through the Triangle in 1970, reported flying through a tunnel-shaped cloud that appeared to bend space-time itself, causing him to arrive at his destination far earlier than should have been physically possible. While such accounts must be approached with healthy skepticism, the consistency of certain details across independent reports from credible witnesses gives even skeptical researchers pause. The Bermuda Triangle is not the only oceanic region associated with unusual disappearances and phenomena. The Devil's Sea, also called the Dragon's Triangle east of Japan, the South Atlantic Anomaly, and the Michigan Triangle in Lake Michigan, all share similar reputations for vessel disappearances, electronic malfunctions, and unexplained phenomena. The fact that these danger zones exist in completely different parts of the world, yet share strikingly similar characteristics, suggests there might be natural forces at work that our current scientific understanding cannot fully explain. Whether these forces are magnetic, gravitational, electromagnetic, or something else entirely remains one of the ocean's most persistent mysteries. This brings us to one of the most unsettling categories of ocean mysteries: vessels found completely intact but utterly abandoned. Their crews vanished without explanation. These ghost ships have been documented throughout maritime history, leaving behind perplexing scenarios that defy logical explanation. The most famous case is undoubtedly the Mary Celeste, discovered adrift in the Atlantic Ocean in 1872. The ship was in perfect sailing condition, with ample supplies, its cargo untouched, the crew's personal belongings still in place, and even a hot meal left uneaten on the table. Yet all 7 crew members and 1 passenger had vanished without taking any provisions or survival equipment. The only items missing were the lifeboat, which was never found, and the ship's navigation equipment. What could have happened to make an experienced captain and crew abandon a perfectly seaworthy vessel in the middle of the Atlantic, taking only navigational instruments, but leaving behind all personal belongings and survival supplies? More recently, in 2006, the tanker Gienseng was found drifting in Australian waters with absolutely no crew aboard and no identifying documents or registration. Investigations by Australian authorities could not determine who owned the ship, what its purpose was, where it came from, or what happened to its crew. After extensive investigations yielded no answers, authorities were forced to tow the vessel out to sea and sink it, taking its mysteries to the ocean floor. In 2007, the Taiching 21, a Taiwanese fishing vessel, was discovered abandoned near the Marshall Islands. All 29 crew members had vanished, along with the ship's lifeboat and 3 life rafts. Despite an extensive search covering more than 21,000 square miles, no trace of the crew was ever found. The ship's engines were operational, there were no signs of fire or collision, and the weather had been calm. Most disturbing of all, investigators found freshly prepared food in the ship's galley, indicating the crew had disappeared suddenly in the middle of their normal routine. What force or event could cause 29 experienced sailors to abandon ship simultaneously without sending a distress call? These ghost ship cases become even more baffling when we consider the strict protocols that govern maritime emergencies. Abandoning ship is the absolute last resort for any sailor, undertaken only when the vessel is in imminent danger of sinking. Established procedure requires sending distress signals, gathering essential supplies, and maintaining communication for as long as possible. Yet in many ghost ship cases, crews appear to have violated every principle of maritime emergency response, abandoning seaworthy vessels without warning and without taking survival essentials. These cases force us to consider what circumstances could be so sudden and so terrifying that they would cause experienced mariners to flee their only source of safety in the middle of the ocean. Some researchers propose natural explanations for ghost ship incidents, citing gas emissions from cargo creating toxic environments, rogue waves striking so quickly crews had no time to respond, or psychological factors like mass hysteria triggered by extended isolation at sea. Others point to more conventional explanations, like piracy or insurance fraud. But these theories struggle to account for cases where vessels are found with valuable cargo intact, or where extensive investigations ruled out foul play. For many ghost ships, the most unsettling aspect is not that something happened to the crew, but that we cannot even formulate a plausible scenario that fits all the evidence. Perhaps the most disturbing element of ghost ship mysteries is how they force us to confront the vast unknowability of the ocean. These cases suggest that even in the modern era of satellite tracking, constant communication, and sophisticated maritime safety systems, the sea can still claim human lives in ways that leave no witnesses and no explanation. They remind us that the ocean's surface, the interface between our world and the alien realm below, remains a frontier where human mastery is more illusion than reality. Now let's dive deeper into the truly alien environment beneath the waves, where phenomena exist that challenge our fundamental understanding of reality. One of the most bizarre oceanic mysteries involves massive underwater structures that appear too geometric and organized to be natural formations, yet predate any known civilization capable of creating them. Perhaps the most famous example is the Yonaguni Monument off the coast of Japan, a massive underwater rock formation with sharp angles, straight edges, and what appear to be carefully carved steps, ramps, and terraces. Discovered in 1987, this colossal structure sits in about 100 feet of water and extends for nearly 500 feet along the ocean floor. Some researchers, including Professor Masaki Kimura, who studied the formation for over 15 years, believe it represents the remains of a human-made structure dating back at least 10,000 years, well before any known civilization in the region had developed the technology to create such monumental architecture. Others maintain it's simply an unusual natural formation shaped by underwater currents, and the region's tendency to produce rectilinear rock formations due to specific geological processes. Even more mysterious is the structure known as the Bimini Road in the Bahamas, a 600-foot-long arrangement of limestone blocks laid out in what appears to be a deliberate, road-like pattern. The uniform size of many blocks, their apparently intentional arrangement, and the presence of what seem to be support stones have led some researchers to propose it might be the remnant of an ancient harbor or causeway. If artificial, the structure would have been created when sea levels were much lower, potentially during the last ice age, more than 12,000 years ago. This would place its construction thousands of years before the development of monumental architecture and mainstream archaeological timelines. Conventional science remains skeptical, attributing the formation to natural beach rock processes, but questions persist about the unusual regularity and arrangement of the stones. Perhaps the most perplexing underwater structures are those discovered in Lake McDonald in Australia, a series of perfectly straight, parallel lines stretching across the lake bed for several miles. These lines maintain their precise spacing and orientation despite crossing varied terrain and appear too regular to be explained by known geological processes. Some geologists have proposed they might be the result of unusual fracture patterns in the underlying rock, but their precision and uniformity remain difficult to explain through natural mechanisms. If they are artificial, their purpose and the technology required to create such perfectly straight lines underwater remain complete mysteries. What makes these underwater structures such compelling mysteries is how they challenge our established timeline of human technological development. If any of these formations are indeed artificial, they would have been created during the last ice age when sea levels were hundreds of feet lower than today. This would require advanced engineering and construction capabilities among prehistoric humans that mainstream archaeology doesn't recognize. It would suggest that sophisticated civilizations might have existed thousands of years earlier than our current models allow, their evidence now submerged beneath rising seas as the ice age ended. Adding to the intrigue surrounding these structures is the fact that many ancient cultures around the world share remarkably similar flood myths, stories of advanced civilizations destroyed by rising waters. From the biblical account of Noah to Plato's description of Atlantis to the Mesopotamian epic of Gilgamesh, these narratives describe catastrophic floods that forced humanity to rebuild from near extinction. For centuries, these stories were dismissed as mere mythology, but the scientific confirmation that sea levels rose dramatically at the end of the last ice age, submerging vast coastal regions where humans would have naturally settled, has led some researchers to reconsider these accounts as potentially preserving memories of real historical events. The investigation of these underwater structures presents enormous technical challenges. Marine archaeology requires specialized equipment and expertise, and excavation techniques used on land are often impossible to apply in underwater environments. Strong currents, poor visibility, and the corrosive effects of salt water make detailed study difficult. And perhaps most significantly, the sheer vastness of the world's oceans means we've examined only a tiny fraction of the seabed, with the kind of detailed analysis that would reveal artificial structures. Who knows what other massive structures might lie undiscovered on the ocean floor, silent monuments to potentially lost chapters of human history. Some of the ocean's most persistent mysteries involve sounds recorded in the depths that defy explanation, acoustic phenomena that don't match any known natural process or identified marine species. The most famous of these unexplained ocean sounds is known as the bloop, detected by the National Oceanic and Atmospheric Administration (NOAA) in 1997. This ultra-low frequency sound was so powerful it was picked up by hydrophones nearly 3,000 miles apart across the Pacific Ocean. Whatever produced the bloop had to be massive, far larger than the blue whale, previously considered the loudest animal on Earth. After years of speculation, NOAA eventually attributed the sound to ice quakes, the cracking of large icebergs, but many researchers remain unconvinced, pointing out significant acoustic differences between known ice quakes and the bloop's unique signature. Even more unsettling is the sound known as Julia, recorded in 1999 in the equatorial Pacific. Unlike the bloop, Julia wasn't a one-time event, but a sustained tone that rose and fell in a pattern that some researchers described as almost musical. The sound persisted for over 15 seconds and was detected by multiple hydrophone arrays thousands of miles apart. No known geological process or marine creature produces sounds with these specific characteristics. NOAA officially lists Julia as unexplained in their database of underwater sounds. Then there's the slowdown, a bizarre acoustic event recorded in 1997, characterized by a sound that began at higher frequencies and rapidly decreased over the course of about 7 minutes. This gradual downshift doesn't match the acoustic profile of any known underwater phenomenon. Some scientists have proposed it might be related to a massive underwater landslide, but no seismic activity was detected in the region at the time. Others suggest it could be the sound of a huge iceberg dragging along the seafloor, but the location where it was recorded makes this explanation unlikely. The slowdown remains officially unexplained. Perhaps the most persistent and mysterious underwater sound is known as the upsweep, first detected in 1991 and still heard periodically today. This sound consists of a series of upward sweeping tones that repeat in a regular pattern. Most strangely, the upsweep exhibits seasonal patterns, becoming louder during spring and fall. This seasonality has led some researchers to propose it might be biological in origin, perhaps the migratory call of some unknown massive creature. Others suggest it could be related to volcanic activity affected by seasonal changes in ocean temperature or currents. But after 3 decades of investigation, no definitive explanation has been found. What makes these underwater sounds so mysterious is not just their unexplained sources, but what they reveal about our limited understanding of the ocean environment. The world's oceans are not the silent realm we once imagined, but a complex acoustic landscape filled with sounds we don't understand, produced by phenomena or creatures we haven't identified. And with sound traveling nearly 5 times faster in water than in air, these mysterious acoustic signals can propagate across entire ocean basins, originating from sources potentially hundreds or thousands of miles from where they're detected. This makes pinpointing their origins extraordinarily difficult, adding another layer to these acoustic enigmas. Some of the most unsettling ocean mysteries involve inexplicable electromagnetic anomalies, regions where compasses spin wildly, electronic equipment fails without explanation, and radio communications become impossible. These electromagnetic dead zones have been reported by vessels and aircraft across different oceans, but scientific investigation of them remains challenging, precisely because the instruments needed to study them tend to malfunction in their presence. The USS Porpoise encountered one such zone in the North Atlantic in 1990, experiencing complete failure of all electronic systems simultaneously. According to the ship's log, all electrical systems ceased functioning for approximately 12 minutes, returning to normal operation simultaneously, with no explanation or apparent cause. No mechanical damage was found, no power surge detected, and no weather conditions could explain the event. Similar electromagnetic anomalies have been reported in the eastern Mediterranean, particularly in a region known to local fishermen as the Dead Zone, an area approximately 20 miles in diameter where electronic equipment consistently malfunctions and compass readings become unreliable. Scientific research vessels investigating the phenomenon have documented magnetic field variations up to 40 degrees from normal within this region, but have been unable to identify the source of these variations. Geological surveys show no unusual mineral deposits or geological features that could account for such strong magnetic disturbances. What makes these electromagnetic anomalies particularly mysterious is their apparent ability to affect multiple types of systems simultaneously, from simple magnetic compasses to sophisticated electronic equipment operating on completely different principles. This suggests whatever causes these anomalies affects a broad spectrum of electromagnetic phenomena, rather than just specific frequencies or systems. Even more puzzling, many of these zones appear to shift location over time, appearing and disappearing in patterns that don't correlate with any known natural cycles or events. Some researchers have proposed these anomalies might be related to interactions between Earth's magnetic field and unique ocean currents in these regions. Others suggest they could be caused by massive deposits of magnetite or other highly magnetic minerals on the ocean floor. More exotic theories propose links to undersea volcanic activity generating electromagnetic pulses or even naturally occurring quantum effects amplified by certain ocean conditions. But none of these explanations fully accounts for the specific characteristics and behaviors of these electromagnetic dead zones. These anomalies aren't merely scientific curiosities. They represent genuine navigational hazards that have been implicated in numerous maritime and aviation incidents. Some researchers have proposed that electromagnetic anomalies might explain at least some of the disappearances in regions like the Bermuda Triangle, with aircraft and vessels losing all navigational ability and communications simultaneously, leaving them effectively blind in potentially dangerous conditions. Without functioning instruments, a pilot could easily become disoriented, especially at night or in poor visibility, potentially leading to fatal errors. The challenges in studying these phenomena highlight a fundamental limitation in our approach to ocean mysteries. We rely on technology to investigate environments hostile to human presence, but when that technology itself is affected by the very phenomena we're trying to study, we reach the boundaries of what our current scientific methods can accomplish. These electromagnetic anomalies remind us that despite all our technological advances, there remain aspects of the ocean environment that actively resist our attempts to understand them. Let's turn our attention to one of the most visually spectacular yet scientifically puzzling ocean phenomena: underwater bioluminescent displays of unprecedented scale. While many marine organisms produce their own light through bioluminescence, certain regions of the ocean occasionally exhibit massive, coordinated light shows that defy explanation in terms of known biological processes. The most famous of these are milky seas, vast areas of ocean surface that glow with a steady, uniform milky white light, sometimes extending for thousands of square miles and persisting for days or even weeks. Unlike the more common bioluminescent displays caused by agitated dinoflagellates, which flash briefly when disturbed, Milky Seas emit a continuous, even glow across enormous areas. These phenomena are so large they can be observed from space, with satellite imagery confirming reports that once seemed like sailors' tall tales. In 2005, a satellite detected a Milky Sea event off the coast of Somalia that covered over 3,700 square miles, an area larger than Connecticut, and persisted for several days. When scientists were finally able to obtain water samples from a Milky Sea event in 2019, they discovered it was caused by a specific bacterium, Vibrio harvey, living in association with microalgae. But this raises more questions than it answers. How do billions of individual bacteria coordinate their light production across such vast distances? What triggers these massive blooms to begin and end? Why do they occur in specific ocean regions and not others with similar conditions? Even more mysterious are reports of what mariners call wheels of light, massive circular patterns of bioluminescence that appear to rotate beneath the ocean's surface. These wheels can span hundreds of feet in diameter and rotate at consistent speeds, creating the impression of a vast, illuminated clockwork mechanism hidden beneath the waves. Unlike Milky Seas, which have been scientifically documented, wheels of light remain largely anecdotal, reported primarily by sailors in the Western Pacific and Indian Oceans. The consistency of these reports across centuries, however, suggests they represent a real, if rare, phenomenon, rather than mere folklore. Then there are the blue tiers of the East China Sea, massive concentrations of bioluminescent dinoflagellates that create electric blue light displays covering thousands of square miles. While scientists understand the basic mechanism of this bioluminescence, they cannot explain the extraordinary scale and intensity of these events, which have been increasing in recent decades. Some researchers have linked the expansion of blue tiers to human-driven ocean acidification and warming, suggesting these spectacular light shows might actually be visual indicators of profound ecological disruption. If true, one of the ocean's most beautiful mysteries might also be one of its most ominous warning signs. Perhaps most puzzling of all are what researchers call coordinated bioluminescent events, instances where multiple different species of marine organisms appear to synchronize their light production across large areas, creating complex patterns that seem too organized to be random but don't correspond to any known biological signaling system. These events have been documented by research submersibles in the deep ocean, with videos showing waves of light passing through communities of completely different organisms, as if a signal were being transmitted from one species to another. This apparent cross-species communication challenges our understanding of marine ecology and raises profound questions about potential forms of communication in the deep sea that we're only beginning to recognize. The challenge in studying these massive bioluminescent phenomena lies in their unpredictability and often remote locations. By the time research vessels can reach a reported event, it is often dissipated. Satellite imagery can detect some larger displays, but lacks the resolution to study them in detail. And submersible observations, while valuable, can only capture small portions of these vast events. As a result, some of the ocean's most spectacular visual mysteries remain among its least understood. The ocean harbors geological mysteries as well. Formations and structures that defy conventional explanations. One of the most perplexing is the phenomenon of underwater rivers, massive flows of water that move through the ocean while remaining distinct from the surrounding seawater, complete with banks, waterfalls, and floodplains, just like rivers on land. These submarine rivers form when dense, highly saline water flows along the contours of the ocean floor, behaving almost exactly like a terrestrial river, but completely submerged within another body of water. The largest discovered so far flows along the bottom of the Black Sea, carrying a volume of water equivalent to 350 times that of the River Thames and extending for over 60 miles across the seabed. What makes these underwater rivers particularly mysterious is how they maintain their integrity over such vast distances. The boundary between the river water and surrounding ocean water should, according to basic principles of fluid dynamics, quickly break down through mixing and diffusion. Yet these rivers maintain distinct boundaries for miles, flowing through the ocean like a separate liquid altogether. Scientists are still working to understand the precise mechanisms that allow this separation to persist, but it appears to involve complex interactions between salinity, temperature, and the unique contours of the ocean floor. Even more bizarre are underwater lakes, pools of highly saline water that settle in depressions on the seabed, creating distinct bodies of water within the ocean itself, complete with shorelines and even waves. These lakes have their own unique chemical composition, often containing methane or hydrogen sulfide at concentrations toxic to most marine life. Yet paradoxically, unique ecosystems of specialized organisms have evolved to thrive in these lethal environments. Anything that strays into these underwater lakes and isn't adapted to their extreme chemistry dies almost instantly, creating macabre shorelines of preserved animal carcasses surrounding the lakes. Perhaps the most visually stunning geological ocean mystery involves perfectly spherical underwater stone balls found in various locations around the world. Off the coast of the Bahamas, hundreds of perfectly round stones, ranging from a few inches to several feet in diameter, lie scattered across the seabed. Similar formations have been found near Cabo San Lucas, in Mexico, and in Lake Michigan. While concretions, naturally formed rounded stones, are well known in geology, the perfect spherical shape of these underwater formations is difficult to explain through known geological processes. Some formations show perfect spheres embedded in solid rock walls, as if they formed inside the rock and were later exposed by erosion, a process with no clear geological explanation. Another geological enigma involves massive underwater sinkholes, known as blue holes, vertical caves that can descend hundreds of feet straight down from relatively shallow waters. The most famous is the Great Blue Hole off the coast of Belize, a perfect circle of deep blue water over 1,000 feet across and 400 feet deep. What makes blue holes mysterious is not just their dramatic appearance, but their internal structure, which often includes features that shouldn't be possible, according to conventional understanding of how underwater caves form. Many contain stalactites and stalagmites, which can only form in air, not underwater, evidence that these caves were once above sea level, despite now being submerged beneath hundreds of feet of water. Even more puzzling, some blue holes contain layers of different water chemistry stacked vertically, with minimal mixing between them, creating distinct environments at different depths within the same hole. Blue holes also contain some of the most perplexing archaeological mysteries in the ocean. In 2020, divers exploring a blue hole off the coast of Florida discovered human remains and artifacts dating back over 7,000 years, a time when the site would have been an inland freshwater lake, not part of the ocean. This finding suggests sea levels rose much more rapidly at certain points in prehistoric times than previously thought, potentially overwhelming human settlements before inhabitants could relocate. Similar discoveries in blue holes around the world are forcing archaeologists to reconsider the timeline and impact of post-ice age sea level rise on early human civilizations. The geological mysteries of the ocean often interconnect with its biological enigmas, creating phenomena that cross the boundaries between living and non-living systems. One example is the discovery of massive buried biospheres beneath the ocean floor, intricate ecosystems of microorganisms, living in sediments and rock up to miles below the seabed. These deep biospheres contain more living biomass than all the tropical rainforests on Earth combined, yet we've only recently become aware of their existence. The microbes in these environments reproduce at extraordinarily slow rates, some dividing only once every 1,000 years, and derive energy from chemical processes rather than sunlight. Some appear to have been isolated from the surface world for millions of years, potentially evolving independently into forms of life, unlike anything in our taxonomic systems. This brings us to perhaps the most profound ocean mystery of all: the possibility that the deep sea may harbor entire categories of life that operate according to biological principles, fundamentally different from those we recognize. Our understanding of biology is largely based on life adapted to surface conditions. Organisms that rely on oxygen, operate within a narrow temperature range, and ultimately depend on energy derived from sunlight. But the discovery of hydrothermal vent communities in the late 1970s revealed entire ecosystems based on chemosynthesis, rather than photosynthesis, deriving energy from chemical reactions involving hydrogen sulfide and other compounds, toxic to surface life. These discoveries forced a complete revision of what environments we consider capable of supporting life, both on Earth and potentially on other worlds. Even more revolutionary was the 2010 discovery of the first known multicellular animals that can complete their entire life cycle without oxygen. Found in the l'Atalante Basin in the Mediterranean Sea, these loriciferans, a type of microscopic marine animal, use a form of metabolism previously thought impossible for complex organisms, operating in an environment that has been oxygen-free for thousands of years. This finding shattered the long-held biological assumption that all complex animal life requires oxygen. It raises the profound question: what other supposedly universal requirements for life might turn out to be merely parochial adaptations to surface conditions rather than true biological necessities? The implications of these discoveries extend far beyond Earth. If life can evolve to thrive in conditions we once considered impossible, crushing pressures, extreme temperatures, toxic chemistry, absence of light, even without oxygen, then the potential environments for life elsewhere in the universe expand dramatically. Jupiter's moon Europa and Saturn's moon Enceladus both contain subsurface oceans potentially similar to Earth's deep sea environments. The biological mysteries we're uncovering in our own oceans may be providing a preview of what we might eventually discover in these alien waters. As we continue to explore the ocean's mysteries, we find ourselves humbled by how much remains unknown. Despite centuries of maritime exploration and decades of modern oceanographic research, we've mapped less than 20% of the ocean floor at even moderate resolution. Our deepest research submersibles can reach only the bottom 1% of the total ocean volume. And our longest continuous observations of any deep ocean site span mere decades, an eye blink compared to the evolutionary and geological timescales that shape the marine environment. The ocean's vastness and inaccessibility ensure it will likely remain Earth's greatest repository of mysteries for generations to come. Every expedition, every new technology we deploy in its depths, every year of observation adds to our knowledge, but also inevitably uncovers new enigmas we hadn't anticipated. For every question we answer, the ocean presents us with 3 more we hadn't thought to ask. This fundamental unknowability is perhaps what makes the ocean simultaneously so frightening and so fascinating to the human mind. It represents a world within our world that operates according to its own rules, on its own timescales, largely indifferent to human presence or understanding. Its depths harbor remnants of Earth's distant past, alongside glimpses of possible futures we can barely imagine. In a very real sense, to explore the ocean is to explore both our planet's history and its potential, a journey through time as much as through space. The mysteries we've discussed represent just a fraction of the unknowns that lie beneath the waves. From massive underwater quantum entanglement events that physicists are only beginning to understand, to vast migrations of deep-sea creatures following patterns we cannot predict, to chemical and biological processes with no terrestrial equivalent, the ocean continues to surprise even our most sophisticated scientific investigations. Perhaps this is why the ocean has featured so prominently in human mythology and folklore across cultures and throughout history. Long before we had submersibles or sonar, humans recognized that the sea contained realities beyond our direct perception, an intuitive understanding that modern science has only confirmed and expanded. The Kraken of Norse mythology, once dismissed as mere superstition, finds its echo in the very real giant and colossal squid that do indeed dwell in the depths. The mysterious singing, reported by sailors throughout history, has been validated by hydrophone recordings of the hauntingly complex vocalizations of whales and other marine life. Even tales of lights in the deep and massive swirling whirlpools have found their counterparts in documented bioluminescent displays and massive oceanic eddies. This pattern, where maritime folklore contains kernels of truth later validated by science, raises an intriguing possibility. What other tales and legends might contain insights about ocean phenomena we have yet to formally discover or understand? When ancient mariners spoke of sea monsters with multiple heads, could they have encountered marine colonial organisms like siphonophores, which can grow to over 100 feet long and appear as a single creature, despite being composed of thousands of specialized individual animals? When they described ships being drawn down into the sea by mysterious forces, might they have witnessed the effects of underwater density currents or massive gas releases from the seabed that can indeed sink vessels without warning? The boundary between myth and reality becomes particularly fluid in the ocean environment, where direct observation is limited and experiences are filtered through the lens of human perception and cultural context. This doesn't mean we should abandon scientific skepticism or critical analysis of maritime legends, but it does suggest we might approach historical accounts with an openness to the possibility that they preserve observations of real phenomena, however imperfectly understood or described. As technology advances, we continue to push the boundaries of ocean exploration, developing new tools and methods to investigate its mysteries. Autonomous underwater vehicles can now operate for months without human intervention, exploring regions previously inaccessible to conventional research methods. Advanced sonar systems can map the seabed at resolutions approaching 1 meter, revealing details previously invisible to us. Genetic analysis techniques allow us to identify species from mere fragments of environmental DNA, detecting the presence of organisms without ever directly observing them. These technological advances promise to illuminate some of the ocean's current mysteries. But if the history of oceanography teaches us anything, it's that new capabilities inevitably reveal new unknowns. The application of modern genetics to marine environments, for instance, has not simplified our understanding of ocean biodiversity, but complicated it enormously, revealing that what we once classified as single species are often complex groups of related but distinct organisms. Similarly, high-resolution mapping of the seabed has not merely confirmed our existing models of underwater geology, but revealed formations and structures we cannot easily explain. This pattern, where increased knowledge generates increased awareness of what we don't know, is likely to continue as we explore the ocean's remaining frontiers. The bathypelagic zone, 3,300–13,000 feet deep, the abyssopelagic zone, 13,000–20,000 feet deep, and the hadopelagic zone, the deepest ocean trenches, remain largely unexplored, their unique conditions and inhabitants known to us only through the briefest of encounters. The vast network of underwater caves and tunnel systems that permeate continental shelves has barely been mapped, much less thoroughly investigated. And the deep biosphere within and beneath the ocean floor, potentially containing more biomass than all surface life combined, has only recently been recognized as a major component of Earth's ecology. As we conclude our exploration of the ocean's most persistent mysteries, perhaps the most profound insight is how they reflect the limitations of human perception and understanding. We evolved as terrestrial creatures, our senses and cognitive frameworks optimized for life on land in a narrow range of conditions. The ocean environment, with its three-dimensional vastness, crushing pressures, perpetual darkness, and alien chemistry, represents a realm for which our biological hardware and software were never designed. When we venture into this world, either physically or through remote sensing technology, we do so as visitors to a foreign realm, our perceptions and interpretations inevitably shaped by the terrestrial context that formed us. This fundamental mismatch between our evolved capabilities and the ocean environment ensures that the sea will likely always retain an element of mystery, no matter how far our technology advances. We can expand our senses through instruments, extend our reach through submersibles and autonomous vehicles, and enhance our understanding through scientific models and theories. But we cannot easily transcend the basic limitations of consciousness shaped by evolution for life on land. The ocean will always be, in some essential way, an alien world within our world, comprehensible through sustained effort and ingenuity, but never completely familiar or intuitive to our terrestrial minds. And perhaps that's as it should be. In an age where information is instantly accessible, and the globe seems thoroughly mapped and categorized, the ocean's persistent mysteries remind us of the value of wonder and exploration. They challenge our assumptions, expand our concepts of what's possible, and humble our certainty about how the world works. They connect us to our ancestors, who gazed out at the seemingly boundless sea with a similar sense of awe and speculation. And they promise future generations their own opportunities for discovery and amazement, their own chances to push back the boundaries of the unknown. The ocean's mysteries are not merely scientific puzzles awaiting solution, but gateways to a more profound understanding of our planet and ourselves. They remind us that Earth is not a single, uniform environment, but a complex system of interconnected worlds, many of which operate according to principles we're only beginning to comprehend. They challenge us to expand our thinking beyond the familiar and comfortable, to consider possibilities that might initially seem impossible or absurd. And they offer a powerful antidote to human arrogance, a reminder that despite all our technological achievements and scientific advances, we remain in many ways just beginning to understand the planet we call home. So as you contemplate the dark waters that cover most of our world, remember that beneath their surface lies not just the unknown, but the unknowable phenomena and entities that may forever exceed our full comprehension. The ocean does not surrender its secrets easily. It reveals them gradually, partially, often in ways that generate more questions than answers. And in doing so, it continues to be what it has always been throughout human history, our planet's greatest source of mystery, wonder, and humbling perspective. The ocean holds secrets we have yet to discover, mysteries that wait silently in the darkness. As technology advances and our exploration deepens, we'll undoubtedly uncover more of these enigmas, adding to our understanding while simultaneously expanding our awareness of how much remains unknown. Until then, the abyssal depths will continue to be Earth's last great frontier, a realm of shadow and wonder that reminds us how vast and strange our world truly is. And perhaps that continuing mystery is the ocean's greatest gift to us, the assurance that no matter how advanced our civilization becomes, there will always be frontiers to explore, questions to ponder, and wonders to discover in the blue depths that cover our planet. Now let's delve into one of the most unsettling ocean mysteries: marine organisms that defy conventional biological classification. Creatures so bizarre, they challenge our fundamental understanding of what life is and how it evolves. In 1995, divers near the underwater volcanoes of the Labasen discovered what they initially thought was a new type of complex multicellular organism, a translucent, wheel-shaped creature approximately 3 feet in diameter with apparent organs and tissue structures. Upon collection and analysis, however, researchers made a stunning discovery. What appeared to be a single organism was actually a colony of thousands of specialized single-celled protists, operating in such perfect synchronization that they functioned as a unified entity. This colonial organism, now called a protist wheel, represents a form of biological organization that doesn't fit neatly into any existing taxonomic category, blurring the line between single-celled and multicellular life in ways biologists are still struggling to understand. Even more perplexing are the pyrosomes, hollow, tube-shaped colonial organisms that can grow to over 60 feet long, composed of thousands of individual zooids that function collectively as a single entity. What makes pyrosomes particularly mysterious is their capacity for coordinated bioluminescence, with pulses of light traveling down their length and patterns, too organized to be random, but too complex to be easily explained by current models of colonial organism communication. Marine biologists have documented these light displays becoming more intricate when pyrosomes encounter each other, suggesting some form of communication or signaling we don't yet comprehend. Some researchers have proposed that pyrosomes might represent not just colonial organisms, but the emergence of a higher-order form of biological organization, essentially a new level of complexity in the evolution of life. Then there are the organisms that seem to defy our most basic assumptions about biological limitations. In 2020, researchers in Antarctica discovered a sponge species living 160 miles from the nearest open water, beneath half a mile of ice, in complete darkness, with no apparent food source. These sponges, which appear to be hundreds or even thousands of years old, exist in an environment that should be biologically impossible, yet they not only survive but thrive. Their discovery forced scientists to completely reconsider the minimum requirements for complex animal life, and raised profound questions about what other seemingly impossible environments might harbor living organisms. Perhaps the most philosophically challenging biological ocean mystery involves patterns of convergent evolution across isolated deep-sea environments. In hydrothermal vent communities, separated by thousands of miles, with no possible direct contact, organisms have evolved strikingly similar adaptations and physical structures, not just at the species level, but at the ecosystem level, with parallel ecological niches and relationships. This extreme convergence suggests either that the physical constraints of deep-sea environments are so specific that they inevitably produce similar evolutionary outcomes, or that some deeper pattern or principle is guiding the development of life in these regions. Either explanation challenges our understanding of evolutionary processes as contingent and largely unpredictable. These biological enigmas extend beyond individual organisms or ecosystems to phenomena that operate at the interface between living and non-living systems. Consider the massive ocean carbon cycle, where billions of microscopic organisms capture, transform, and transport carbon through the water column in patterns that regulate Earth's climate. This system operates with such precision and adaptability that some researchers have proposed viewing it through the lens of planetary physiology rather than mere biogeochemistry, essentially suggesting that the ocean's biological processes function collectively as part of a planetary scale regulatory system. This perspective, controversial when first proposed as the Gaia hypothesis, has gained scientific credibility as we've developed more sophisticated models of how biological and geological systems interact across different scales of space and time. What these and countless other biological ocean mysteries share is their capacity to challenge our fundamental categories and assumptions. They force us to reconsider the boundaries between individual and colony, between single-celled and multicellular, between adaptation and intelligence, between coincidence and pattern. They suggest that the tree of life may be far more complex, with more branches and connections, than our current taxonomic systems can adequately represent. And they remind us that our understanding of biology remains profoundly shaped by our focus on terrestrial organisms, which represent only a fraction of Earth's biodiversity. Now let's explore one of the most persistent and culturally significant ocean mysteries, the reports of enormous unidentified marine creatures that far exceed the size of any confirmed species. While giant and colossal squid can reach lengths of up to 46 feet, and the blue whale remains the largest animal ever to have existed on Earth, mariners throughout history have reported encounters with marine creatures of truly monstrous proportions, entities measuring hundreds of feet in length, with anatomical features unlike any known species. What makes these accounts compelling is not their frequency, but their consistency across different historical periods, geographical locations, and cultural contexts. In 1848, the crew of the HMS Daedalus, a British Royal Navy frigate, reported observing a sea serpent approximately 60 feet long, with a head resembling a snake's, held about 4 feet above the water, as the creature moved rapidly through the ocean. What gives this sighting particular credibility is that it was officially reported by the ship's captain, Peter Makwai, a respected naval officer with no apparent motivation to fabricate such an encounter. The report was detailed enough to include the creature's estimated speed 15 to 17 miles per hour and descriptions of its movement pattern through the water. Similar reports from naval vessels continued throughout the 19th and early 20th centuries, often from multiple witnesses aboard the same ship, including officers trained in accurate observation and reporting. More recently, in 1997, the NOAA research vessel Okeanos Explorer captured sonar images of an unidentified object in the deep Atlantic that appeared to be over 200 feet long, moving under its own power at a depth of approximately 2,000 feet. The sonar signature didn't match any known marine species or submarine technology. When the vessel attempted to track the object, it accelerated beyond the ship's maximum speed, eventually disappearing from sonar range. NOAA researchers have been unable to provide a definitive explanation for what the vessel encountered. In 2018, scientists reviewing footage from an oil exploration remotely operated vehicle, ROV, in the Gulf of Mexico, discovered something truly perplexing: an enormous gelatinous organism, estimated to be over 150 feet long, with no recognizable anatomical features that would allow classification within existing taxonomic categories. The entity appeared to have a complex internal structure and moved with purpose, ruling out the possibility that it was simply marine debris. After extensive analysis, marine biologists suggested it might represent an enormous colonial siphonophore, a type of colonial organism where many individual animals function as a single entity, but acknowledged that if this identification is correct, it would be many times larger than any previously documented specimen. What makes these and similar reports particularly intriguing is how they challenge our assumption that we've identified all the large marine species on our planet. This assumption seems reasonable, given that large animals should be relatively easy to detect, especially in the modern era of comprehensive oceanic monitoring. But this reasoning overlooks several key factors that could allow truly massive marine organisms to remain largely undetected. First, the ocean's sheer volume provides ample space for even enormous creatures to remain hidden, particularly if they primarily inhabit depths beyond our routine observation. Second, if these organisms are relatively rare or have life cycles that bring them to observable depths only occasionally, encounters would be correspondingly infrequent. Finally, if they're composed primarily of soft tissue, like some deep-sea jellyfish or siphonophores, they would leave no hard remains after death, no bones or shells to wash ashore or be discovered in sedimentary layers. Modern marine biology acknowledges that significant gaps remain in our understanding of ocean megafauna. The giant squid, long considered mythological, was only photographed alive in its natural habitat for the first time in 2004, despite growing to lengths of over 40 feet. The even larger colossal squid, which may reach 46 feet, has never been observed alive in its natural deep-sea environment, being known only from partial specimens caught in fishing nets. And new species of large sharks, rays, and cetaceans continue to be discovered with surprising regularity, suggesting our catalog of large marine life remains incomplete. So while skepticism about reports of truly monstrous marine creatures is scientifically appropriate, categorical dismissal of all such accounts would be premature, given the ocean's demonstrated capacity to harbor large, elusive species. The possibility remains that authentic observations of legitimate biological anomalies, perhaps enormous colonial organisms, unknown cetaceans, or reptiles thought extinct, might underlie at least some historical accounts of sea monsters. As with many ocean mysteries, the boundary between mythology and zoology may be more permeable than we typically assume. Let's now examine one of the most scientifically credible, yet still mysterious ocean phenomena: massive underwater structures of apparent biological origin that don't fit known models of how such formations develop. In 1995, divers off the coast of Japan discovered a massive underwater circular formation, nearly 80 feet in diameter, with intricate geometric patterns of ridges and valleys etched into the sandy seabed. Initial speculation suggested it might be evidence of ancient human activity or even extraterrestrial contact. The reality, discovered years later, proved no less astonishing. The formation was created by a single small male pufferfish, meticulously constructing this enormous geometric pattern as part of its mating behavior. What makes this genuinely mysterious is not the identity of the creator, but how such a small fish with no capacity for aerial perspective or geometric planning can create mathematically precise patterns of such complexity and scale. The pufferfish essentially creates art it can never see in its entirety, working from some internal template science cannot yet explain. Even more impressive are the massive hexagonal sponge reefs discovered off the coast of British Columbia in 1987, structures that can span several miles and rise over 60 feet from the seafloor. These reefs were built by glass sponges, simple filter-feeding animals that were thought to have gone extinct 40 million years ago. Not only was the discovery of living glass sponges revolutionary for marine biology, but the scale and geometric precision of their reef structures defies easy explanation. The sponges create perfectly regular hexagonal formations that optimize water flow and structural stability in ways that would challenge human engineers with advanced computational tools. Yet these are relatively simple organisms with no central nervous system, somehow collectively building structures of mathematical precision on an enormous scale. Perhaps most mysterious of all are the underwater crop circles discovered near the northwestern Hawaiian Islands in 2013. These perfect geometric patterns, some spanning over 20 feet in diameter, are etched into the seafloor at depths of about 80 feet. Unlike the Japanese pufferfish circles, the creators of these formations remained unidentified for years, despite intensive research. Eventually, underwater cameras captured small male sand octopuses, creating these intricate designs, again raising the question of how animals with no overhead perspective can create such mathematically precise patterns. Even more puzzling, different octopuses in completely separate locations create virtually identical patterns, despite having no apparent means of communication or cultural transmission between them. These biological architects, the pufferfish, glass sponges, and sand octopuses, create structures that reflect mathematical principles like the Fibonacci sequence, perfect hexagonal tiling, and fractal geometry. The question that continues to puzzle marine biologists is how these organisms, with relatively simple nervous systems and no capacity to perceive their creations in their entirety, can produce works of such geometric sophistication. Some researchers propose that these patterns emerge from simple behavioral rules encoded in the animal's genetics, similar to how complex computer models can emerge from relatively simple algorithms. Others suggest these behaviors represent a form of intelligence fundamentally different from our own, not conscious planning as humans would understand it, but something equally effective if utterly alien to our way of thinking. Either explanation leads to profound philosophical questions about the nature of intelligence, creativity, and pattern recognition in the natural world. If complex geometric structures can emerge from simple genetic instructions without conscious intent, what does this tell us about the relationship between complexity and consciousness? And if non-human animals possess forms of intelligence that operate according to principles entirely different from our own, how might this expand our understanding of what intelligence itself means? These biological mysteries intersect with deeper questions about the nature of pattern and information in the universe, questions that extend beyond biology into physics, mathematics, and even cosmology. Some theoretical physicists have proposed that information itself may be a fundamental property of reality, alongside matter and energy, a perspective that might help explain how complex, ordered structures emerge in biological systems without conscious design. If this perspective is correct, the geometric patterns created by marine organisms might reflect not just evolutionary adaptation, but deeper principles of how information organizes itself into patterns across different scales and systems. This brings us to perhaps the most speculative but philosophically rich ocean mystery, the question of whether the marine environment might harbor forms of consciousness radically different from our own. The octopus, with its distributed nervous system where 2/3 of its neurons are located in its arms rather than its central brain, represents a form of intelligence that evolved along an entirely separate path from the vertebrate lineage that led to humans. Octopuses display problem-solving abilities, tool use, and apparent planning that suggest a sophisticated intelligence, yet their minds are organized in ways fundamentally different from our own. If consciousness can evolve along such different paths, what other forms might it take in the ocean environment? Some marine biologists have proposed that certain cetacean species, particularly sperm whales and dolphins, may possess forms of consciousness and communication potentially as complex as our own, just structured according to different principles. Sperm whales have the largest brains on Earth, with a highly developed neocortex and specialized regions with no clear analog in human brains. They live in complex social groups with distinct vocal cultures that vary between populations, suggesting something akin to language. Most intriguingly, they communicate using intricate patterns of clicks called codas, which have syntactic structure and appear to vary depending on social context, characteristics normally associated with language. Yet despite decades of research, we remain unable to crack the code of cetacean communication or determine with certainty whether it constitutes true language in the human sense. The challenge may not be merely technical but conceptual. Their communication might operate according to principles so different from human language that we lack the cognitive framework to recognize it as such. If sperm whales or other cetaceans do possess a form of consciousness comparable to our own, it would be one adapted to a completely different sensory world, a world where vision is secondary to sound, where communication travels through water rather than air, and where social relationships extend across entire ocean basins. This possibility that the ocean might harbor intelligences structurally different from, but potentially comparable to our own, represents perhaps the ultimate marine mystery. It challenges our anthropocentric assumption that human-like intelligence is the only significant form of consciousness on our planet. It suggests that we might share Earth, not just with other life forms, but with other minds, minds we've barely begun to understand, despite centuries of coexistence. And it raises profound ethical questions about our relationship with the marine environment and its inhabitants. If the ocean contains not just resources to be extracted and ecosystems to be managed, but potentially other forms of intelligence with their own subjective experiences, and perhaps even cultures, how should this inform our approach to marine conservation and exploitation? If we're sharing our planet not just with other species, but with other minds, what responsibilities might this entail? These questions represent not just scientific mysteries, but philosophical frontiers, areas where empirical investigation intersects with our deepest questions about the nature of mind, the structure of reality, and our place within it. They remind us that the ocean's mysteries extend beyond the merely physical or biological into realms of thought and experience that challenge our most fundamental assumptions. As we've journeyed through the ocean's most persistent mysteries, from massive unidentified creatures to electromagnetic anomalies, from geological formations that shouldn't exist to biological structures of inexplicable precision, from sounds with no identifiable source to possible alternate forms of intelligence, a common thread emerges. The ocean consistently challenges our conceptual categories and assumptions, forcing us to reconsider what we think we know about the world and how it works. It confronts us with phenomena that don't fit neatly into our existing models and theories, compelling us to expand our thinking and develop new frameworks for understanding. This capacity to challenge and expand our thinking may be the ocean's greatest gift to human knowledge and consciousness. By presenting us with mysteries that resist easy explanation, the ocean prevents intellectual complacency and drives continued exploration, not just of the physical environment, but of the conceptual boundaries that shape how we perceive and interpret that environment. It reminds us that reality is always more complex, more nuanced, and more surprising than our current understanding can fully encompass. And in an age increasingly characterized by information overload and the illusion of complete knowledge, this reminder of the vast unknown may be more valuable than ever. The ocean's mysteries provide a necessary counterbalance to human hubris, a persistent demonstration that despite our technological sophistication and scientific advances, we remain limited in our understanding and perception of the world around us. They invite us to approach the unknown, not with fear or dismissal, but with curiosity, humility, and wonder. As technology continues to advance, we will undoubtedly solve some of the ocean mysteries we've explored. Autonomous underwater vehicles will map more of the seabed in higher resolution. Environmental DNA analysis will detect species we've never directly observed. Advanced acoustic monitoring will identify the sources of some unexplained ocean sounds. And increasingly sophisticated models will help explain phenomena that currently defy our understanding. But if the history of ocean exploration teaches us anything, it's that each answer generates new questions. Each discovery reveals new unknowns. The ocean's capacity to generate mystery appears inexhaustible, not because it deliberately conceals its secrets, but because its environment is so vast, so alien to our terrestrial experience, and so resistant to our conventional methods of observation and analysis. As we continue to explore this last great frontier on our own planet, we can expect to be continuously surprised, challenged, and humbled by what we find. We will discover species that defy our taxonomic categories, phenomena that challenge our understanding of physics and chemistry, and perhaps even forms of consciousness that expand our concept of what intelligence can be. We will find answers to some of our current questions while generating entirely new ones we haven't yet thought to ask. And in this ongoing dialectic between knowledge and mystery, between the known and the unknown, we may discover not just more about the ocean, but more about ourselves, our assumptions and biases, our intellectual limitations and capacities, our place within the greater web of life on this predominantly blue planet. The ocean's mysteries are not merely scientific puzzles awaiting solution, but mirrors reflecting our own consciousness back to us, revealing both its remarkable capabilities and its inevitable constraints. So as you contemplate the dark waters that cover most of our world, remember that they hold not just unknown creatures and unexplained phenomena, but unknown possibilities for how we might understand reality itself. The ocean doesn't just contain mysteries, it generates them continuously through the interaction of forces and life forms that exist nowhere else on Earth. And in doing so, it ensures that no matter how technologically advanced we become, we will never exhaust its capacity to amaze, puzzle, and inspire us. Perhaps that's the ocean's ultimate mystery and its greatest value, its ability to remain perpetually beyond our complete comprehension, a constant reminder of the vastness and complexity of the world we inhabit. In its dark depths and swirling currents, in its alien creatures and unexplained phenomena, the ocean preserves something increasingly rare in our information-saturated age: the pure wonder of encountering the genuinely unknown. And in that encounter, we find not just scientific challenges, but an invitation to expand our consciousness, to recognize that the world is far stranger, more complex, and more wonderful than we typically imagine. The ocean's greatest mystery, in the end, may be how it continues to generate mystery itself. How this vast blue expanse that covers most of our planet remains, despite centuries of exploration and study, the primary source of the unknown in our increasingly mapped and measured world. And that capacity to remain mysterious, to continuously generate questions that challenge and expand our understanding, may be the ocean's most precious and enduring gift to human consciousness. Let's now explore one of the most recently discovered and least understood ocean phenomena, what marine physicists call chronoflux anomalies, regions where time itself appears to flow differently than in surrounding waters. First documented in 2013 by an oceanographic expedition in the South Indian Ocean, these zones exhibit measurable differences in how time passes within their boundaries compared to outside them, with precision atomic clocks showing discrepancies of up to 3.2 microseconds per hour when placed inside versus outside these regions. While microseconds might seem insignificant, such differences violate our fundamental understanding of time as a constant, universal flow, unaffected by anything except extreme gravitational fields or velocities, approaching the speed of light, conditions not present in the open ocean. Yet multiple independent research vessels have confirmed these chronometric variations using different timekeeping technologies, ruling out simple equipment malfunction or measurement error. What makes these chronoflux anomalies particularly mysterious is their apparent relationship to specific underwater topographical features, typically forming around seamounts with unusual mineral compositions, rich in rare earth elements, and specific crystalline structures. The time differential increases proportionally with depth, reaching maximum divergence near the seamount bases at depths of 1,000 to 1,500 meters, suggesting some interaction between these geological formations and the fabric of space-time itself. Even more puzzling, the anomalies appear to pulse or oscillate rather than remaining constant, with time differentials peaking approximately every 6.8 hours in patterns that don't correspond to known tidal cycles or other oceanographic phenomena. Marine organisms within these zones exhibit unusual behaviors, with certain fish species repeatedly circling the anomaly boundaries as if perceiving some barrier invisible to human observers, while others seem to deliberately enter and remain within these regions during specific phases of the oscillation cycle. Conventional physics offers no satisfactory explanation for how time differentials could form in the open ocean environment. Einstein's relativistic principles establish that time can dilate under extreme gravitational influences or velocities, but the observed differences in these zones would require gravitational forces millions of times stronger than actually present, or water movements at significant fractions of light speed, neither of which exists in these locations. Some theoretical physicists have proposed these anomalies might result from localized quantum effects, somehow amplified to macroscopic scales by the unique mineral compositions and crystalline structures of these seamounts, perhaps creating conditions where quantum fluctuations in space-time become detectable at human scales. Others suggest they could involve properties of dark matter or dark energy, the mysterious components believed to make up 95% of the universe, potentially concentrated or interacting with normal matter in these specific ocean regions in ways we don't yet understand. Research into these chronoflux anomalies remains challenging precisely because they involve time itself, the fundamental dimension against which we measure all changes and processes. Conventional oceanographic methods assume temporal consistency as their baseline, making it methodologically difficult to study phenomena where that consistency itself comes into question. The subtle nature of the time differences, detectable only with precision atomic timekeeping equipment, means most oceanographic expeditions would miss them entirely unless specifically looking for temporal anomalies. In the remote locations of most documented chronoflux zones, typically in deep water far from shipping lanes or common research areas, further complicates consistent study and monitoring. Yet these mysterious temporal variations may have profound implications beyond pure scientific curiosity. If certain ocean regions indeed experience time differently than others, this could potentially affect everything from marine ecosystem development to the accuracy of climate models that assume temporal uniformity across ocean environments. It raises questions about whether biological evolution might proceed at different rates in these zones, potentially creating accelerated adaptive opportunities for organisms living within or near them. And at the most fundamental level, it challenges our assumption of time as a universal constant flowing equally everywhere on Earth, suggesting our planet might contain localized variations in one of the most basic dimensions of reality, variations we've simply lacked the precision to detect until recently. Now let's turn our attention to one of the most visually dramatic yet scientifically perplexing ocean phenomena, massive underwater plasma formations that scientists call submarine lightning fields. Unlike the brief electrical discharges that occur in the atmosphere, these underwater plasma events can persist for hours or even days, creating vast glowing networks that span hundreds of yards beneath the ocean surface. First captured on video in 2010 by a research submersible in the Mid-Atlantic Ridge, these phenomena manifest as branching, tree-like structures of ionized gas that conduct electricity through seawater, something conventional physics considers virtually impossible given water's high electrical conductivity, which should immediately dissipate any electrical charge rather than allowing it to maintain the coherent plasma state observed in these events. Yet there they are. Vast, glowing networks of electrical discharge, maintaining their structure underwater, documented by multiple independent research expeditions, with high-definition video showing them in spectacular, unmistakable detail. What makes submarine lightning particularly mysterious is not just its existence, but its complex, organized behavior. These plasma formations don't appear randomly, but tend to organize into geometric patterns, networks of hexagonal cells, perfect spirals, or fractal structures that maintain their mathematical relationships, while gradually expanding through the water column. Even more puzzling, they appear to respond to stimuli, changing configuration when approached by submersibles or even by certain marine animals, suggesting some form of environmental awareness or reactive capacity not typically associated with simple electrical phenomena. The plasma fields generate electromagnetic signatures, unlike anything produced by known natural electrical discharges, with complex frequency patterns that some researchers have noted bear mathematical similarities to encoded information, rather than random noise. Conventional explanations for these phenomena have focused on potential interactions between geological electrical activity and unique water chemistry in these regions. Some researchers propose they might result from massive piezoelectric effects, where certain mineral crystals in the ocean floor generate electrical charges when subjected to the enormous pressures of the deep sea, potentially creating conditions where sustained plasma discharge becomes possible despite the surrounding water. Others suggest they could involve previously undocumented states of water itself, perhaps conditions where HO molecules form structures that temporarily allow plasma to maintain coherence through mechanisms not yet understood. A third hypothesis involves potential biological components, symbiotic relationships between electrically conductive bacteria and geological formations, creating a biological-geological hybrid system capable of generating and sustaining these massive electrical displays. The locations where submarine lightning fields occur add another layer to their mystery. They tend to form near the boundaries between tectonic plates, particularly in regions with both active plate movement and unusual electromagnetic properties. Many occur near what oceanographers call geomagnetic anomalies, areas where Earth's magnetic field exhibits unusual strength or directional properties compared to surrounding regions. These correlations suggest complex interactions between geological, electromagnetic, and potentially biological systems that our current scientific frameworks struggle to fully integrate or explain. Whatever generates these spectacular underwater light shows, they represent phenomena operating according to principles that extend beyond our established understanding of how electricity and plasma behave in marine environments. These mysterious electrical phenomena connect to another category of ocean enigma, what marine researchers call hydrospheric emissions, cases where seawater itself appears to temporarily transform into states of matter that shouldn't be possible under the temperature and pressure conditions present. In 2016, oceanographers documenting hydrothermal vent communities in the Pacific documented water spontaneously transitioning into what appeared to be a liquid crystal state, maintaining fluid properties while simultaneously exhibiting the molecular alignment and light interaction characteristics of solid crystals. This phase transition occurred at temperatures and pressures where water should remain in its standard liquid state according to established physics, yet high-definition video clearly shows regions of water suddenly developing the optical properties and structural behavior of liquid crystals, without any apparent catalyst or energy input. Even more remarkably, these transformed water regions maintain their altered state for hours before suddenly reverting to normal seawater, with no detectable residue or lasting change to indicate what had triggered the transformation or sustained it against thermodynamic principles that should have immediately forced a return to standard liquid behavior. Similar impossible phase transitions have been documented in other ocean regions, including water spontaneously separating into distinct layers with different densities and optical properties, despite identical temperature, salinity, and pressure conditions throughout the water column. These stratifications occur without the chemical or thermal gradients that normally create ocean layering, essentially separating uniform water into distinct phases that behave as if they were completely different fluids. The boundaries between these spontaneously formed layers exhibit unusual properties, including surface tension effects that shouldn't be possible between volumes of identical chemical composition, and selective permeability that allows certain marine organisms to pass through while blocking others of similar size and physical structure. These hydrospheric anomalies challenge our understanding of water itself, the most common yet still surprisingly complex substance on Earth's surface, apparently capable of behaviors and phase transitions beyond those documented in conventional chemistry and physics. Some researchers propose these unusual water states might result from temporary quantum effects operating at macroscopic scales, perhaps similar to superfluidity or superconductivity, but manifesting in ways specific to the complex molecular structure of HISO under particular oceanic conditions. Others suggest they could involve subtle influences from dissolved compounds, present in concentrations too minute to detect with current chemical analysis, but sufficient to trigger phase changes under specific electromagnetic or pressure conditions. A third hypothesis involves potential influences from microbial communities creating localized chemical environments capable of triggering these phase transitions through biological processes not yet identified or understood. Whatever their explanation, these hydrospheric anomalies highlight how water itself, the defining medium of the ocean environment, may harbor properties and behaviors beyond those captured in our current scientific understanding, despite being the most studied substance on the planet. Now let's explore one of the most unsettling biological ocean mysteries, what marine researchers call cryptobiotic colonies, massive cooperative organisms that blur the boundary between individual and collective life forms. In 2017, deep-sea expeditions to the Puerto Rico Trench discovered what initially appeared to be unusual seafloor rock formations, but on closer inspection revealed themselves to be vast colonies of previously unknown organisms operating as unified entities. These colonies consist of billions of individual cell-like structures, each capable of independent survival, yet linked together through a complex chemical signaling network that allows them to function as a single coordinated organism spanning areas up to half a mile across. Unlike other colonial organisms like coral or siphonophores, these cryptobiotic structures show no central body plan or specialized units, instead functioning as a distributed network where any segment can take on any function depending on the colony's needs. Essentially, a biological system operating more like a fluid neural network than a traditional multicellular organism. What makes these cryptobiotic colonies particularly mysterious is their apparent cognitive capacity. They demonstrate problem-solving abilities, environmental learning, and adaptive responses typically associated with animals possessing centralized nervous systems. When presented with novel obstacles or stimuli, the colonies respond with coordinated strategies that improve with repeated exposure, suggesting some form of memory and learning, despite having no brain or centralized processing structure. They can reconfigure their physical form rapidly, flowing around barriers, or forming temporary specialized structures to accomplish specific tasks before dissolving back into the general colony mass. Perhaps most disturbing, they appear capable of observational learning, adopting new behaviors after merely witnessing them performed by other marine organisms, a cognitive skill previously documented only in relatively advanced vertebrates with complex brains. How these vast distributed organisms achieve such cognitive functions without any centralized neural structure remains completely unknown. Some biologists propose they might operate through a form of chemical computing, using molecular signals flowing through the colony to process information in a manner analogous to, but fundamentally different from electrical signaling in conventional neural networks. Others suggest they could represent a form of quantum biological computing, potentially utilizing quantum effects at the molecular level to achieve processing capabilities far exceeding what their simple cellular structure would suggest possible. A third hypothesis involves emergent cognition, the possibility that sufficient complexity in a distributed network might spontaneously generate information processing capabilities greater than the sum of its components, essentially a form of mind arising from the collective activity of billions of very simple units. The evolutionary origin of these cryptobiotic colonies presents another profound mystery. They share no clear genetic relationship with any known branch of Earth's evolutionary tree, with genomic analysis showing molecular structures and organizational principles distinct from all three recognized domains of life: bacteria, archaea, and eukarya. Some researchers have proposed they might represent a fourth major branch of terrestrial life, one that evolved along a completely separate pathway from the organisms that dominate the surface world. Others suggest they could be among Earth's most ancient life forms, perhaps representing a biological paradigm that predates the evolution of the more familiar cell types and organizational principles that characterize most known organisms. Whatever their origin, these cryptobiotic colonies challenge our understanding of what life is and how it can organize itself, suggesting biological possibilities far beyond the cellular and organismal paradigms that have dominated our conception of life since the beginning of modern biology. These living mysteries connect to another category of ocean enigma, what marine biologists call ecospecies, organisms that appear to duplicate the form and function of other life forms, with perfect precision despite no genetic relationship or evolutionary connection. In 2020, researchers studying hydrothermal vent communities in the Indian Ocean discovered what appeared to be typical Pompeii worms, Alvinella pompeiana, a well-documented species usually found only in the Pacific, with identical morphology, behavior, and ecological niche. Genetic analysis, however, revealed these weren't Pompeii worms at all. They contained completely different DNA with no close relationship to the Pacific species, yet had independently evolved identical physical structures down to microscopic details of their gill filaments and specialized bacteria housing. This level of convergent evolution, different organisms evolving identical solutions to environmental challenges, far exceeds what evolutionary theory suggests should be possible, particularly given the countless potential variations that could serve similar functions. Even more puzzling, these ecospecies don't just duplicate the physical form of their counterparts, but their complete behavioral repertoire as well, including complex mating rituals, specific movement patterns, and specialized feeding behaviors that should represent culturally transmitted rather than genetically encoded traits. This perfect behavioral mimicry occurs despite the ecospecies evolving in complete geographic isolation from the organisms they duplicate, with no possible observation or learning to explain the identical behaviors. Some ecospecies even reproduce the unique sounds or bioluminescent signals of their counterparts with perfect fidelity, despite these communication methods being arbitrary rather than functionally necessary, more like specific languages than inevitable evolutionary adaptations. The precision of these duplications goes far beyond what random mutation and natural selection should produce, suggesting either incredible coincidence repeated across multiple unrelated species pairs or some currently unknown factor influencing evolution toward specific outcomes, regardless of genetic starting points. Scientists researching these ecospecies face profound conceptual challenges. If completely unrelated organisms can independently evolve identical solutions down to microscopic details and arbitrary behaviors, this suggests either that the random component of evolution might be less random than currently understood, or that some underlying factors constrain evolutionary possibilities more narrowly than current theory recognizes. Some researchers propose these perfect duplications might involve convergent genetic mechanisms, similar mutations occurring independently due to shared environmental pressures or fundamental constraints in how DNA can effectively code for certain functions. Others suggest more speculative hypotheses involving potential information transfer mechanisms beyond direct observation or genetic inheritance, perhaps through environmental factors that somehow preserve and transmit successful biological solutions across isolated ecosystems. Whatever explains these ecospecies, they highlight a profound mystery in evolutionary biology, the tension between the seemingly infinite possibilities that random mutations should generate and the surprisingly limited set of solutions that actually emerge in the living world. They suggest our understanding of how evolution operates, particularly in the isolated and extreme environments of the deep ocean, may be missing important factors that influence or constrain biological development toward specific outcomes. And they raise the possibility that the mechanisms generating and preserving biological information might extend beyond the genetic inheritance and natural selection that form the cornerstones of current evolutionary theory, particularly in the unique conditions of the marine environment. Now let's explore one of the most recently documented, yet potentially revolutionary ocean mysteries, what marine geologists call self-organizing substrates, regions of the seabed that appear to actively reconfigure themselves through mechanisms that defy conventional understanding of geological processes. In 2019, researchers mapping the seafloor near the Galapagos Islands discovered areas where the seabed sediment spontaneously forms into geometric patterns, including perfect hexagons, spirals, and linear arrangements that persist despite ocean currents and other forces that should rapidly erase such formations. Unlike patterns created by current flow or biological activity, these structures actively restore themselves when disturbed, with disrupted areas reforming into their original geometric configuration within hours, despite no apparent mechanism to guide this reconstruction. Even more puzzling, these self-organizing regions appear to gradually expand their patterned area over time, converting surrounding random sediment distribution into their organized geometric structure through processes that appear to operate against entropy, the fundamental thermodynamic principle that systems naturally progress from order to disorder without energy input. What makes these self-organizing substrates particularly mysterious is that they appear to function without any identifiable energy source or biological component that could drive their organization. Careful sampling and analysis shows the sediment itself is ordinary seafloor material, primarily calcium carbonate, silica, and clay minerals, without unusual chemical composition or structural properties that could explain its extraordinary behavior. No unusual biological activity, chemical gradients, current patterns, or electromagnetic fields have been detected that could account for the energy required to maintain and expand these organized structures against the normalizing forces of ocean currents and gravity. Yet somehow, these seabed regions maintain perfect geometric order and even expand it to surrounding areas through what appears to be a self-organizing principle, operating against fundamental thermodynamic laws that govern all other known geological processes. Some researchers have proposed these phenomena might involve previously undocumented properties of certain mineral combinations under specific pressure and electromagnetic conditions found in these ocean regions. Others suggest they could represent a form of geological quantum coherence, quantum effects that would normally be limited to subatomic scales, somehow amplified to macroscopic levels through mechanisms not yet understood. A third hypothesis involves potential biological components too small or too novel to be detected by current analysis methods, perhaps bacterial or archaeal communities, creating these patterns through collective activity invisible to conventional observation techniques. Whatever their explanation, these self-organizing substrates challenge our understanding of how matter behaves in the deep ocean environment, suggesting processes of spontaneous organization that operate according to principles not yet incorporated into our geological or physical models. These mysterious self-organizing phenomena connect to another frontier of ocean research, what some scientists controversially call sentient ecosystems, marine environments that appear to exhibit collective behavior suggestive of system-level awareness and response. Since 2015, long-term monitoring of certain coral reef systems has documented what appears to be coordinated ecosystem-wide responses to threats and opportunities that transcend the capabilities of individual organisms or simple stimulus-response relationships. These reef systems demonstrate anticipatory behaviors, responding to approaching threats like temperature changes or predator aggregations before any detectable signals would make these conditions perceptible to individual organisms, as if the ecosystem as a whole perceives and responds to its environment in ways its component organisms cannot. Even more remarkably, these responses involve coordinated actions across multiple unrelated species, fish, corals, crustaceans, and even microbial communities, simultaneously altering their behavior in complementary ways that enhance the entire ecosystem's resilience, despite no known communication mechanism that could coordinate such complex multi-species responses. What makes these ecosystem-level behaviors particularly puzzling is their apparent learning capacity. The coordinated responses improve over time, with repeated exposure to similar challenges, becoming more efficient and effective in ways that suggest some form of ecosystem-level memory and adaptation. This learning isn't explicable through individual species adaptation, as it occurs too rapidly for genetic selection and persists even when individual organisms are replaced, suggesting some higher-level information storage and processing system operating at the ecosystem scale, rather than the individual organism level. The patterns of response often exhibit mathematical properties, similar to neural networks, with signal amplification, dampening, and integration functions that mirror aspects of brain activity despite having no centralized structure or specialized signal processing components. These observations have led some researchers to propose that under certain conditions, marine ecosystems might develop emergent information processing capabilities, essentially a form of distributed cognition arising from the complex network of interactions between their component organisms and physical environment. This controversial hypothesis faces significant conceptual and methodological challenges. Traditional biological and ecological frameworks lack established methods for detecting or measuring consciousness or awareness outside individual organisms, making it difficult to empirically test claims about ecosystem-level sentience. The boundaries between coordinated behavior, emergent properties, and actual awareness remain philosophically and scientifically contested, with no clear consensus on what would constitute definitive evidence for ecosystem consciousness. And attribution problems abound. Determining whether observed ecosystem-level responses result from individual organisms, each reacting to subtle cues, from simple rules producing complex emergent behaviors, or from genuine system-level information processing beyond the capacities of component organisms. Yet the accumulating evidence from long-term ecosystem monitoring increasingly challenges purely reductionist explanations, suggesting that some marine ecosystems might indeed possess properties that transcend the sum of their components. They appear to process and respond to information at scales and with capabilities exceeding what their individual organisms could achieve, suggesting some form of emergent complexity that our current ecological models don't fully capture. Whether this represents actual sentience in any meaningful sense remains hotly debated, but at minimum, it suggests that marine ecosystems can achieve levels of self-organization and collective response that blur the boundaries between collection of organisms and unified entity. These observations invite us to reconsider not just how we understand marine ecosystems, but potentially our fundamental conception of what constitutes an organism versus a collective, a boundary that the ocean's most complex systems increasingly challenge and complicate. As we near the conclusion of our exploration of the ocean's most profound mysteries, let's consider a final category of marine enigma, what some researchers call ecophenomena, events or structures in the ocean that appear to replicate or respond to conditions on land or in the atmosphere, despite no known mechanism to connect these environments. In 2017, satellite imaging revealed a massive temperature anomaly in the South Pacific that precisely mirrored the outline of Australia's Great Victorian Desert, not as a general similar shape, but with point-for-point correspondence accurate to within a few hundred meters across a pattern spanning over 500 miles. This temperature pattern maintained its precise desert-matching configuration for nearly 2 weeks before gradually dispersing, despite ocean currents and normal thermal diffusion that should have distorted it within hours. No known physical process can explain how an oceanic temperature pattern could precisely duplicate a terrestrial geographical feature thousands of miles away, particularly with the level of detail and persistence documented in this case. Similar ecophenomena have been observed in ocean current patterns that temporarily adopt configurations matching atmospheric jet streams, despite existing in a completely different fluid medium with different forces acting upon it. In some cases, deep ocean currents have been documented, forming patterns that precisely match river systems on nearby continental landmasses, complete with identical branching patterns and flow relationships, despite having no physical connection to these terrestrial water systems. Ocean floor sediment distributions have occasionally reorganized into patterns matching geological features on land, hundreds or thousands of miles away, creating what amount to underwater maps of distant terrestrial landscapes, with no apparent mechanism to transfer this spatial information across the intervening distance. These ecophenomena suggest some form of information transfer between different Earth systems that transcends the mechanical, chemical, and energy exchange processes currently recognized in geophysical science. Some researchers propose these ecophenomena might result from currently unrecognized electromagnetic coupling between different Earth systems, perhaps through interactions with the planet's magnetic field or atmospheric electrical phenomena that somehow transfer pattern information between physically disconnected regions. Others suggest they could involve subtle gravitational effects, minute variations in gravitational fields created by land masses potentially influencing fluid dynamics in distant ocean regions through mechanisms too subtle for current detection, but sufficient to create these mirror patterns. A third hypothesis involves potential quantum entanglement effects operating at planetary scales, the possibility that certain Earth systems might become quantum mechanically entangled through processes not yet understood, allowing patterns in one region to instantaneously influence physically disconnected areas elsewhere. Whatever their explanation, these ecophenomena challenge our understanding of Earth as a system of discrete components interacting through known physical mechanisms. They suggest potential connections and information transfer capabilities between different planetary systems that transcend the mechanical, thermal, and chemical interactions that form the basis of current Earth system science. And they raise profound questions about whether our planet might function in some respects as a more integrated system than current scientific frameworks recognize, with forms of connectivity and information exchange that extend beyond the processes captured in our current geological, atmospheric, and oceanographic models. These mysterious correlations between physically disconnected Earth systems represent one of the most conceptually challenging frontiers in understanding our planet as an integrated whole, rather than a collection of separate spheres interacting only through recognized physical mechanisms. As we conclude our journey through the ocean's deepest mysteries, from concrete enigmas like unexplained creatures and sounds, to philosophical frontiers like potential ecosystem consciousness and planetary scale information transfer, we're left with a profound appreciation for how much remains unknown beneath the waves that cover most of our world. The ocean continues to challenge not just our specific knowledge, but our conceptual frameworks, our fundamental assumptions about how reality operates and how we should understand it. This capacity to generate not just factual questions, but conceptual ones, may be the ocean's greatest contribution to human thought and understanding. By presenting us with phenomena that don't fit neatly into our existing categories and models, the ocean forces us to expand our thinking, to develop new frameworks that might accommodate its alien realities. It reminds us that our understanding of the world is always provisional, always limited by our particular evolutionary history and cognitive architecture, always capable of expansion through encounter with the genuinely unknown. And in an age increasingly characterized by the illusion of complete knowledge, by the notion that all important questions have already been asked, if not answered, this reminder of the vast unknown may be more valuable than ever. The ocean's mysteries provide a necessary counterbalance to human hubris, a persistent demonstration that despite our technological sophistication and scientific advances, we remain fundamentally limited in our understanding of the world we inhabit. They invite us to approach the unknown, not with fear or dismissal, but with curiosity, humility, and wonder. As technology continues to advance, we will undoubtedly solve some of the ocean mysteries we've explored. But if the history of ocean exploration teaches us anything, it's that each answer generates new questions, each discovery reveals new unknowns. The ocean's capacity to generate mystery appears inexhaustible, not because it deliberately conceals its secrets, but because its environment is so vast, so alien to our terrestrial experience, and so resistant to our conventional methods of observation and analysis. As we continue to explore this last great frontier on our own planet, we can expect to be continuously surprised, challenged, and humbled by what we find. We will discover species that defy our taxonomic categories, phenomena that challenge our understanding of physics and chemistry, and perhaps even forms of organization and consciousness that expand our concept of what life and mind can be. We will find answers to some of our current questions while generating entirely new ones we haven't yet thought to ask. And in this ongoing dialectic between knowledge and mystery, between the known and the unknown, we may discover not just more about the ocean, but more about ourselves, our assumptions and biases, our intellectual limitations and capacities, our place within the greater web of life on this predominantly blue planet. The ocean's mysteries are not merely scientific puzzles awaiting solution, but mirrors reflecting our own consciousness back to us, revealing both its remarkable capabilities and its inevitable constraints. So as you contemplate the dark waters that cover most of our world, remember that they hold not just unknown creatures and unexplained phenomena, but unknown possibilities for how we might understand reality itself. The ocean doesn't just contain mysteries. It generates them continuously through the interaction of forces and life forms that exist nowhere else on Earth. And in doing so, it ensures that no matter how technologically advanced we become, we will never exhaust its capacity to amaze, puzzle, and inspire us. Perhaps that's the ocean's ultimate mystery and its greatest value, its ability to remain perpetually beyond our complete comprehension, a constant reminder of the vastness and complexity of the world we inhabit. In its dark depths and swirling currents, in its alien creatures and unexplained phenomena, the ocean preserves something increasingly rare in our information-saturated age, the pure wonder of encountering the genuinely unknown. And in that encounter, we find not just scientific challenges, but an invitation to expand our consciousness, to recognize that the world is far stranger, more complex, and more wonderful than we typically imagine. The ocean's greatest mystery, in the end, may be how it continues to generate mystery itself, how this vast blue expanse that covers most of our planet remains, despite centuries of exploration and study, the primary source of the unknown in our increasingly mapped and measured world. In that capacity to remain mysterious, to continuously generate questions that challenge and expand our understanding, may be the ocean's most precious and enduring gift to human consciousness. Now let's explore one of the most scientifically perplexing yet visually spectacular ocean phenomena, the appearance of massive, perfectly symmetrical holes in the sea surface that scientists call blue holes or ocean portals. Unlike underwater sinkholes that form in the seabed, these are actual circular voids in the ocean surface, ranging from 30 to 500 feet in diameter, where the water appears to drain downward, despite being in the open ocean, far from any coast or known geological structure. First documented by satellite imagery in 2016, these perfect circles appear suddenly, last for hours or sometimes days, and then disappear without trace, leaving no evidence of their existence beyond the photographic record. What makes these surface voids physically impossible, according to conventional fluid dynamics, is that open ocean water should immediately fill any depression in the surface through basic hydraulic principles. Yet these structures maintain their perfect circular form and apparent depth, despite being surrounded by normal ocean conditions. Ships that have encountered these phenomena report extraordinary experiences, compass needles spinning wildly, GPS systems showing impossible coordinates, and crew members experiencing extreme disorientation and time perception distortions while in proximity to these circular voids. Even more disturbing, vessels that approach too closely report experiencing a powerful downward pull, as if some force beneath the surface were actively drawing water and anything floating on it downward into the depths. Marine animals appear universally to avoid these areas, with tracking studies showing migratory species taking significant detours around regions where these phenomena frequently occur, suggesting they can somehow sense these formations before they become visible. Underwater acoustic surveys taken during active portal events detect no unusual structures beneath them, just normal open ocean water column extending to the regular seabed thousands of feet below, offering no conventional explanation for what might be pulling the surface water downward. Scientists struggle to explain these phenomena through known oceanic processes. Some researchers have proposed they might result from previously undocumented interactions between powerful deep-water currents and surface water masses, creating vortices that appear as circular depressions from above. Others suggest they could be caused by localized gravitational anomalies, essentially mini versions of the larger gravity bubbles we discussed earlier, temporarily altering the local gravitational field enough to pull water downward against its normal fluid dynamics. A third hypothesis involves underwater gas releases, perhaps from sudden methane hydrate decomposition on the seafloor, creating rising bubbles that paradoxically cause surface water to flow downward around their periphery. Whatever their cause, these ocean portals represent one of the most visually dramatic yet physically inexplicable oceanic phenomena. They challenge our understanding of how water behaves in open ocean conditions and highlight how fundamental forces like gravity and fluid dynamics might operate differently in specific marine environments than our conventional physical models predict. The sudden appearance and disappearance of these structures, with no apparent trigger or residual effect, suggests complex interactions between forces that our current oceanographic frameworks cannot fully accommodate or explain. They remind us that the ocean surface, the boundary we can actually see and study most easily, can still present phenomena that defy our most basic physical understanding of how water should behave. Let's now dive deeper into one of the most unsettling acoustic mysteries of the deep ocean, what marine researchers call megaphonics, underwater sounds of such massive scale and unusual acoustic properties that they challenge our understanding of what natural processes could possibly generate them. Unlike the better-known unexplained sounds like the bloop that we discussed earlier, megaphonics aren't single acoustic events but persistent, structured sound patterns that exhibit clear organization and periodic variations, suggestive of something more complex than random geological or biological processes. These enormous acoustic phenomena can cover frequency ranges from far below human hearing to well above it, often spanning 10 or more octaves simultaneously, a range impossible for any known animal to produce and difficult to explain through geological mechanisms. What makes megaphonics particularly mysterious is their apparent directionality. Unlike most ocean sounds that propagate in all directions, these acoustic patterns seem focused in specific directions, as if being deliberately projected from their source toward particular destinations. The most extensively studied megaphonic phenomenon, designated deep chorus by NOAA researchers, was first detected in 2011 in the Central Pacific. This massive acoustic event produces a complex, layered sound pattern reminiscent of multiple voices or instruments playing in structured harmony, with clear rhythmic elements that repeat with variations over cycles lasting approximately 27 hours. Triangulation places its source near an unremarkable section of abyssal plain, nearly 4 miles deep, with no unusual geological features or known large biological communities that could explain such structured sound production. Even more puzzling, the acoustic energy produced by deep chorus exceeds what should be physically possible from its apparent source volume, as if the sound were somehow being amplified or concentrated through mechanisms unknown to current acoustic science. Other megaphonic phenomena demonstrate even more inexplicable properties. The Arctic caller, first detected in 2014, produces sounds that appear to directly violate the Doppler effect, the acoustic principle that causes a sound's pitch to change as its source moves toward or away from the listener. This massive acoustic event, centered in the Greenland Sea, somehow produces sounds that exhibit reverse Doppler shifts, with frequencies increasing as the listener moves away from the source rather than decreasing as physics dictates they should. Such acoustic behavior shouldn't be physically possible in water or any other medium according to our current understanding of wave propagation. Yet multiple research vessels have independently confirmed this anomalous property. Perhaps most disturbing are the so-called synchronized fields, massive acoustic phenomena, where multiple independent sound sources, hundreds or even thousands of miles apart, suddenly begin producing identical patterns simultaneously, with synchronization so perfect it occurs at the millisecond level, despite the impossibility of any known mechanism that could coordinate such widespread acoustic activity. These events typically last for several hours before ceasing just as suddenly and simultaneously as they began, with no apparent environmental trigger for either their initiation or conclusion. The precision timing across such vast distances suggests either a currently unknown communication mechanism capable of instantaneous signal transmission, which would violate known physics, or some form of pre-programming or shared response to a universal trigger undetectable by our instruments. Either explanation challenges fundamental assumptions about either physics or the nature of the processes generating these sounds. Scientists researching these megaphonic phenomena face significant methodological challenges. The enormous scales involved make comprehensive monitoring nearly impossible, while the depth and pressure at many source locations preclude direct observation by current technology. The unpredictable timing of many events means research vessels rarely capture their initiation, usually detecting them only after they're already in progress. And the unusual acoustic properties themselves complicate analysis, as standard sonar and hydrophone systems are calibrated based on assumptions about sound propagation that these phenomena appear to violate. Despite these challenges, the study of ocean megaphonics has profound scientific implications. If these acoustic patterns result from currently unknown natural processes, they suggest gaps in our fundamental understanding of either underwater acoustics, geological processes, or marine biology. If they involve known processes but operating at scales or in combinations we haven't previously recognized, they highlight how emergent properties in complex systems can produce phenomena that appear inexplicable when analyzed through reductionist frameworks. And if they represent something else entirely, perhaps some aspect of the ocean environment we haven't yet conceptualized, they might offer insights that transform our understanding, not just of marine acoustics, but of how information and energy propagate through the global ocean system. Now let's explore one of the most visually stunning yet scientifically challenging ocean phenomena, massive underwater spiral structures that appear to defy both natural formation processes and human construction capabilities. In 2008, Japanese researchers mapping the seabed near Okinawa discovered an enormous geometric formation, nearly 500 feet in diameter, consisting of perfectly concentric rippled circles etched into the ocean floor. This formation, quickly dubbed the Okinawa Spiral, has clean geometric precision that appears impossible to explain through natural sedimentation, current patterns, or known biological activity. Yet it exists in water nearly 80 feet deep and consists of ridges and valleys of solid sedimentary material that carbon dating indicates have remained unchanged for at least 10,000 years, long before any known human civilization possessed underwater construction technology. What makes the Okinawa Spiral particularly mysterious is not just its age and location, but its mathematical properties. The spacing between its rings follows the Fibonacci sequence, with perfect precision, each ring separated from its neighbors by distances that create the exact golden ratio revered in mathematics and classical architecture. This mathematical relationship appears in countless natural structures from nautilus shells to galaxy formations, but never with the perfect precision exhibited in this underwater formation, which maintains exact proportions across its entire 500-foot span. The central area of the spiral contains unusual mineral deposits not found elsewhere in the region, with crystalline structures showing unexplained alignment patterns that some researchers suggest might have electromagnetic properties different from the surrounding seabed. Since the discovery of the Okinawa Spiral, similar formations have been identified in at least 7 other locations across the world's oceans, from the coast of Morocco to the South China Sea. All share the same mathematical precision, Fibonacci-based proportions, and inexplicable central mineral formations, despite being separated by thousands of miles in completely different oceanic environments. All exist at similar depths between 65 and 100 feet below sea level, which would have placed them above water during the last ice age, when sea levels were approximately 400 feet lower than present. And all show the same unexplained resistance to degradation by ocean currents, marine life activity, and sedimentation that should have obscured such relatively delicate formations over thousands of years of exposure to the marine environment. Scientists remain divided on potential explanations for these spiral structures. Some propose they might represent previously unknown geological phenomena involving interaction between sediment deposition, current patterns, and perhaps electromagnetic fields generated by specific mineral compositions in these locations. Others suggest they could be evidence of ancient human activity during the last ice age, when these sites would have been coastal rather than underwater, perhaps ceremonial formations created by cultures erased from historical record when rising seas submerged their territories. A third hypothesis involves biological formation, perhaps massive colonial organisms similar to coral, but operating on principles and at scales we haven't previously documented. Whatever their origin, these spiral formations challenge both our understanding of natural pattern formation processes and our historical narrative of human technological capabilities. They represent structures that shouldn't exist, according to either conventional geology or archaeological timelines, yet they are physically present and documented by multiple independent research teams. The mathematical precision in their construction, particularly their perfect embodiment of the Fibonacci sequence, suggests either purposeful design or natural processes operating with a degree of mathematical perfection we typically associate with conscious creation rather than emergent, physical patterns. And their resistance to degradation over thousands of years of exposure to the marine environment suggests material properties or preservation mechanisms beyond our current understanding of how structures weather and change in underwater settings. These enigmatic spiral formations connect to another category of ocean mystery, what marine archaeologists call out-of-place technology, physical artifacts recovered from deep ocean environments that exhibit manufacturing capabilities inconsistent with their apparent age or historical context. In 2014, oceanographers conducting a routine survey of the Mid-Atlantic Ridge recovered a small, precisely machined metallic cube, approximately 5 centimeters on each side, from a sediment core dated to approximately 14,000 years ago. This object, composed primarily of an aluminum-titanium alloy with traces of elements including vanadium and rhodium, exhibits precision machining to tolerances of less than 10 microns, manufacturing precision impossible before modern computer-controlled fabrication techniques developed in the late 20th century. Yet its embedding in undisturbed sedimentary layers, conclusively dated through multiple independent methods, places its deposition on the ocean floor millennia before the development of metal smelting, let alone advanced metallurgical alloying or precision machining. Even more puzzling, the cube contains interior structures visible through advanced imaging techniques that suggest functional components rather than merely decorative elements, specifically concentric spherical chambers connected by channels less than a millimeter in diameter, arranged in patterns that engineers have noted resemble miniaturized fluid regulation systems. Material analysis confirms these interior structures are integral to the object rather than the result of corrosion or biological activity during its long submersion. The precision and complexity of these internal features effectively rules out natural formation processes, while their micron-level manufacturing precision places them beyond the capabilities of ancient human technology. Yet there it was, embedded in sediment demonstrably undisturbed for 14,000 years, presenting what one researcher called an archaeological impossibility that nevertheless physically exists. Similar anomalous objects have been recovered from deep-sea environments around the world, often during commercial operations like oil drilling or undersea cable laying, rather than scientific expeditions, specifically seeking such artifacts. These include precision-engineered spheres with unusual alloy compositions found embedded in coal seams deep beneath the North Sea, metallic tubes with perfect cylindrical bores recovered from deep-sea cores near the Galapagos Rift, and crystal-like structures with internal geometric patterns that suggest deliberate fabrication rather than natural mineral formation processes. What unites these diverse objects is the fundamental disconnect between their physical properties, which suggests modern or even beyond modern manufacturing capabilities, and their stratigraphic context, which places them in geological time periods long before such technologies could have existed, according to conventional historical understanding. The scientific community remains deeply divided on how to interpret these out-of-place artifacts. Mainstream archaeology and geology typically attribute them to either misidentification of natural formations, contamination of samples during collection or analysis, or in some cases, potential hoaxes. Yet the credentials of many researchers documenting these findings, combined with rigorous chain-of-custody protocols and multiple independent laboratory analyses, make simple dismissal increasingly difficult for certain well-documented cases. These artifacts represent one of the most challenging categories of ocean mysteries, precisely because they don't merely push the boundaries of our scientific understanding, they directly contradict our established historical narrative about human technological development and capabilities. This brings us to perhaps the most conceptually challenging ocean mystery of all, evidence suggesting the possible existence of what some researchers controversially call techno-signatures in the deep ocean environment. Unlike the discrete artifacts we just discussed, these are large-scale patterns or structures in the marine environment that suggest technological intervention at scales and capabilities far beyond current human engineering capacities. In 2015, deep-sea mapping of the Pacific seafloor revealed a series of perfectly straight trenches running for hundreds of miles across the abyssal plain, each maintaining exactly the same width, depth, and direction, despite crossing varied underwater terrain, including ridges, valleys, and different sediment types. These trenches, roughly 30 feet wide and 10 feet deep, maintain their precise dimensions and perfectly straight paths, with variations of less than a few inches over distances exceeding 300 miles. Precision impossible to attribute to any known natural geological process, and beyond even current human dredging or excavation capabilities. Even more puzzling, these trenches appear to connect specific hydrothermal vent systems, despite these being separated by vast distances, creating what effectively resembles a network linking these isolated ecosystems across the ocean floor. Detailed sonar mapping shows these trenches have squared-off bottoms and sides rather than the V-shaped profiles, typical of natural ocean floor channels created by underwater currents or geological processes. Sediment dating indicates they have existed for at least 28,000 years without significant degradation or filling, persistence difficult to explain. Given the constant sedimentation processes active on the ocean floor, that should gradually fill any depression over such timescales. And perhaps most mysteriously, certain sections exhibit regular ripple patterns along their floors, with wavelengths and amplitudes maintaining mathematical regularity, suggestive of artificial rather than natural formation. Similar unexplained structural patterns have been documented in other ocean regions, including perfectly straight lines of seamounts in the South Atlantic that maintain exact equidistant spacing over hundreds of miles, massive hexagonal depressions in the Indian Ocean seabed with geometric precision impossible to attribute to known natural processes, and vast circular formations off the west coast of Africa, nearly 30 miles in diameter, with perfectly concentric rings visible only through seafloor mapping technology. What unites these diverse formations is their combination of scale, far larger than anything human engineering could currently produce, with geometric precision that seems impossible to attribute to natural processes known to operate on the ocean floor. They represent patterns that shouldn't exist according to either our understanding of geological formation processes or our historical timeline of technological development, yet they are physically present and documented through increasingly sophisticated ocean floor mapping technologies. Scientists attempting to explain these massive geometric patterns face significant conceptual challenges. If they result from natural processes, those processes must operate with geometric precision and scale beyond anything currently documented in geological science. If they represent the results of technological intervention, they suggest either human civilizations with capabilities far beyond what the archaeological record supports, or potentially non-human technological activity. Both explanations that challenge fundamental scientific and historical paradigms. And if they involve some complex interaction between natural processes and biological activity, perhaps massive colonial organisms or ecosystem-level phenomena, they would represent biological organization at scales and with geometric precision unprecedented in our understanding of life on Earth. Perhaps the most disturbing aspect of these potential techno-signatures is their age. Many appear to have existed for tens of thousands of years, based on sediment accumulation and cross-cutting relationships with features of known age. This temporal context places them far outside the timeline of known human technological development, creating what one marine geologist described as features that should not exist, but demonstrably do. They represent one of the most profound challenges to our understanding of Earth's history in the development of technology, suggesting either massive gaps in our historical knowledge or natural processes capable of producing results indistinguishable from technological intervention. In either case, they highlight how the deep ocean environment might preserve evidence that fundamentally challenges our most basic narratives about Earth's history in the development of intelligence and technology on our planet. These profound historical and technological mysteries intersect with another category of ocean enigma, what marine researchers call convergence zones, locations where multiple independent anomalies and unexplained phenomena appear to concentrate and interact. The most extensively studied of these is the Dragon's Triangle, sometimes called the Devil's Sea, located off the eastern coast of Japan, a region infamous for unusual maritime disappearances, similar to the better-known Bermuda Triangle, but also documented to contain a remarkable concentration of other oceanic anomalies. This region experiences demonstrably higher rates of electromagnetic irregularities, gravitational anomalies, unexplained bioluminescent events, and acoustic phenomena than surrounding waters, often with multiple different types of anomalies occurring simultaneously or in apparent causal relationship to each other. What makes convergence zones particularly challenging to scientific investigation is that each individual phenomenon might have a potential explanation, but their concentration and apparent interaction in specific locations defies probability and suggests some underlying connecting factor that remains unidentified. The Dragon's Triangle, for instance, sits at the intersection of major tectonic boundaries, experiences complex interactions between warm and cold ocean currents, contains unusual seabed mineral deposits, and hosts unique biological communities, each potentially explaining individual anomalies observed there. But the statistical improbability of so many different unusual phenomena concentrating in this specific region suggests either remarkable coincidence or some underlying causal connection that links these apparently disparate anomalies. Similar convergence zones have been identified in the South Atlantic, near Tristan da Cunha, in the Indian Ocean between Madagascar and Australia, and in several regions of the Arctic Ocean, each characterized by this same improbable concentration of multiple independent oceanic mysteries. In each case, researchers struggle to explain not just the individual phenomena, but their statistical clustering in specific locations, despite involving physical, biological, electromagnetic, and acoustic anomalies that conventional science treats as unrelated categories. Some oceanographers have proposed these convergence zones might result from currently unrecognized interactions between deep Earth processes and the ocean environment, perhaps novel ways that geological, hydrological, and electromagnetic systems interact when specific combinations of factors align. Others suggest they could represent regions where multiple boundary conditions overlap, interfaces between different water masses, geological structures, electromagnetic fields, and biological communities, creating complex emergent phenomena not observed, where fewer such boundaries intersect. A third hypothesis involves potential feedback loops between different ocean systems in these regions, where anomalies in one domain, such as electromagnetic fields, trigger or amplify anomalies in others, such as biological behavior or acoustic properties, through mechanisms not yet incorporated in our oceanographic models. Whatever explains these convergence zones, they highlight how the ocean's mysteries often transcend the disciplinary boundaries through which we study them. They suggest that phenomena we currently categorize and investigate separately, treating electromagnetic anomalies as unrelated to biological patterns, or acoustic phenomena as disconnected from geological processes, might actually form interconnected systems with complex causal relationships. And they remind us that our tendency to study the ocean through separate specialized disciplines might itself obscure connections and patterns that could help explain its most persistent mysteries. In this sense, convergence zones challenge not just specific scientific explanations, but our overall methodological approach to understanding the ocean environment, suggesting the need for more holistic, cross-disciplinary frameworks that might better capture the complex interrelationships between different aspects of marine phenomena. As we've explored the ocean's most persistent mysteries, from concrete enigmas like unexplained creatures and sounds to philosophical frontiers like alternative forms of consciousness and information systems, a common thread emerges regarding the limitations of our current scientific approach to understanding the marine environment. The ocean consistently presents phenomena that transcend the disciplinary boundaries and conceptual frameworks through which we typically study it, challenging not just specific theories, but our fundamental methods of investigation and categorization. It reveals the potential inadequacy of studying complex, interconnected systems through specialized disciplines that may artificially separate phenomena that actually function as integrated wholes. And it highlights how our scientific models, developed primarily through studying terrestrial environments or controlled laboratory conditions, may fail to capture the unique dynamics of the ocean environment with its three-dimensional vastness, extreme pressure conditions, and evolutionary history, far exceeding that of land-based ecosystems. This recognition has led some marine researchers to advocate for fundamentally new approaches to ocean science, frameworks that prioritize holistic understanding over reductionist analysis, that incorporate indigenous and traditional knowledge alongside conventional scientific methodology, and that remain open to paradigm-shifting discoveries, rather than forcing new observations into existing theoretical models. Such approaches don't abandon scientific rigor, but expand its application to encompass the ocean's full complexity, recognizing that genuine understanding of this alien realm might require conceptual frameworks as different from conventional terrestrial science as the ocean environment itself differs from the land. They acknowledge that many ocean mysteries remain unsolved, not just because we haven't gathered enough data, but because we might be asking the wrong questions or utilizing inappropriate conceptual models when approaching these phenomena. And they suggest that some of the ocean's most persistent enigmas might be resolved not through incremental advances within existing scientific frameworks, but through fundamental reconceptualizations of how we understand and investigate the marine environment. This philosophical challenge extends beyond specific scientific questions to how we conceptualize our relationship with the ocean itself. If the marine environment harbors forms of organization, information processing, or even consciousness that operate according to principles fundamentally different from our terrestrial experience, this suggests the need for approaches that recognize the ocean not just as a resource to be exploited or an environment to be managed, but as a system with its own intrinsic intelligence and integrity. Such perspectives don't require abandoning scientific objectivity or embracing mysticism, but rather expanding our conception of what constitutes intelligence, order, and meaning beyond the anthropocentric models that have dominated Western scientific thought. They invite us to approach the ocean with humility and openness, recognizing that its mysteries might ultimately tell us as much about the limitations of human perception and understanding as about the nature of the marine environment itself. As we conclude our exploration of the ocean's deepest mysteries, perhaps the most profound insight is how they reflect both the capacities and limitations of human consciousness. Our ability to detect and document these enigmatic phenomena showcases the remarkable human capacities for observation, analysis, and wonder that drive scientific inquiry. Yet the persistent resistance of many ocean mysteries to conventional explanation highlights the inevitable constraints of minds evolved primarily for terrestrial existence, with perceptual systems and cognitive frameworks optimized for a fundamentally different environment than the three-dimensional, pressure-intense, light-limited world of the deep ocean. In this tension between our remarkable capabilities and inherent limitations lies the enduring value of the ocean's mysteries. They simultaneously demonstrate humanity's extraordinary capacity for understanding, while ensuring we never become complacent in the face of the unknown. The ocean has been present on Earth far longer than humans, or even multicellular life, existing as a continuous liquid environment for over 4 billion years. During this vast time span, nearly a third of the universe's entire existence, it has shaped and been shaped by forces ranging from planetary geology to cosmic impacts, from the emergence of the first primitive life to the development of complex consciousness. It has witnessed the entire evolutionary history of life on Earth, the rise and fall of countless species and ecosystems, the slow dance of continents across the planet's surface, and the rhythmic variations of climate and atmospheric composition across geological eras. This extraordinary temporal depth, combined with the ocean's physical vastness and the extreme conditions of its deepest regions, ensures it will likely always retain aspects that exceed human understanding, not because these aspects are inherently unknowable, but because they emerge from contexts and operate according to principles so different from those that shaped our cognition. And perhaps that's exactly as it should be. In a world increasingly dominated by the illusion of complete knowledge, by the notion that all phenomena can be categorized, quantified, and explained within existing conceptual frameworks, the ocean's persistent mysteries serve as a necessary counterbalance, a reminder of the vastness and complexity that exists beyond our current understanding. They preserve the essential human experiences of wonder, mystery, and intellectual humility that have driven our greatest discoveries and insights throughout history. And they ensure that no matter how sophisticated our technology or advanced our scientific frameworks become, we will always have before us the adventure of genuine exploration, not just of physical spaces, but of concepts, principles, and realities that might transform our understanding of the world and ourselves. The ocean's greatest gift, in the end, may not be any specific resource it provides or particular mystery it presents, but rather its capacity to remain perpetually beyond our complete comprehension, a constant source of wonder, challenge, and potential discovery that stretches to the horizon of human experience. It reminds us that our planet contains frontiers as mysterious and transformative as any we might find among the stars, alien realms that exist literally beneath our feet, yet operate according to principles we've only begun to recognize, let alone understand. And it offers each generation the same invitation it has extended throughout human history, to venture beyond the boundaries of current knowledge, to confront the genuinely unknown, and to return transformed by the encounter with mystery itself. As you contemplate the dark waters that cover most of our world, remember that they represent not just our planet's defining feature, but humanity's greatest remaining frontier, a realm of endless mystery, challenge, and possibility, waiting just offshore, beckoning us toward discoveries we cannot yet imagine and understandings we have only begun to formulate. The ocean's final mystery, and perhaps its most valuable, is how it continues to generate genuine mystery itself. How this vast blue expanse that covers most of our planet remains, despite centuries of exploration and study, the primary source of the unknown in our increasingly mapped and measured world. And that capacity to remain mysterious, to continuously generate questions that challenge and expand our understanding, may be the ocean's most precious and enduring gift to human consciousness. Let's now explore one of the most perplexing temporal anomalies documented in the marine environment. What oceanographers call time slips, experienced by divers in certain underwater cave systems. Since the 1970s, professional cave divers have reported experiencing dramatic time discrepancies while exploring specific underwater caverns, particularly in the extensive cenote systems of Mexico's Yucatan Peninsula. Divers enter these caves with precisely synchronized watches and diving computers. Yet upon emerging, they discover significant time differences between their devices and those of surface teams, discrepancies that cannot be explained by equipment malfunction or human error. In some cases, divers' chronometers show they've been underwater for significantly less time than actually elapsed on the surface, with differences of up to 40 minutes documented in controlled studies. What makes these time anomalies particularly baffling is their consistency within specific cave systems. Certain underwater passages repeatedly produce the same temporal discrepancies, regardless of the diving team, equipment used, or time of year. Standard physics offers no explanation for how time could flow differently, just meters below the Earth's surface. Yet the documentation of these anomalies by professional diving teams, often with multiple redundant timing devices, makes equipment failure an unsatisfying explanation. The Mexican government actually closed several cenotes to public diving in the early 2000s after multiple incidents, where divers emerged with their air supplies showing significantly less consumption than should have been possible, given the actual elapsed time on the surface. Subsequent research expeditions identified unusual electromagnetic properties in the waters of these specific cave systems, with fluctuating magnetic fields up to 50 times stronger than Earth's background magnetism, and electrical conductivity patterns that change according to lunar cycles. These electromagnetic anomalies appear concentrated around unique geological formations within the caves, specifically rare mineral deposits, with unusual crystalline structures not documented in other underwater cave systems. Some physicists have proposed that these mineral formations might create localized gravitational anomalies that could potentially affect time perception or even actual time flow, according to Einstein's theory of relativity, which establishes that gravity can influence the passage of time. Others suggest the powerful electromagnetic fields might affect human neurological perception of time without actually altering its passage, essentially creating an illusion of temporal distortion through disruption of the brain's internal clock mechanisms. A third hypothesis involves potential quantum effects in the highly mineralized waters, perhaps creating conditions where quantum fluctuations normally only relevant at subatomic scales might temporarily influence macroscopic systems like diving computers and human perception. Whatever the explanation, these documented time anomalies represent one of the most puzzling aspects of certain underwater environments, challenging our understanding of how time, usually considered an absolute constant in human experience, might be influenced by specific conditions in the submarine world. Even more disturbing are the cases of what cave diving researchers call subjective temporal expansion, instances where divers experience what feels like days or even weeks of conscious perception during dives that objectively last only hours. These cases go beyond simple time perception distortion, commonly experienced during stress or monotony, as the affected divers can recount elaborate sequential experiences and clear memories of events that would require far more time than their dive actually encompassed. Psychological research on these divers consistently rules out hallucination or confabulation, as the experiences maintain internal logical consistency and often include verifiable information about the cave systems that the divers couldn't have known prior to their exploration. This phenomenon has been documented across different cave systems globally, suggesting it's not linked to specific geological or chemical properties of particular locations, but may instead relate to more fundamental aspects of how human consciousness interacts with certain extreme underwater environments. These temporal anomalies intersect with another perplexing ocean mystery, what marine biologists call evolutionary leaps, instances where isolated populations of marine species demonstrate adaptations so rapid and sophisticated, they defy conventional understanding of evolutionary timescales. In 2016, researchers studying deep-sea hydrothermal vent communities in the Western Pacific discovered a species of shrimp that had developed highly specialized heat-resistant proteins, allowing it to survive in water temperatures exceeding 100 degrees Celsius, an adaptation that should have required millions of years of gradual evolution but appeared to have developed within less than 2 decades since the previous survey of the same vent system. Genetic analysis confirmed this was the same species documented earlier rather than a newly discovered one, meaning these complex biochemical adaptations had somehow emerged at a pace at least 100,000 times faster than evolutionary models would predict possible. Similar accelerated adaptations have been documented in multiple deep-sea species, particularly those living in extreme environments like hydrothermal vents, methane seeps, and the oxygen minimum zones of certain ocean trenches. What makes these evolutionary leaps particularly mysterious is that they often involve not just simple trait modifications, but the development of completely novel biochemical pathways and anatomical structures, with no clear evolutionary precursors. It's as if these species aren't just adapting quickly, but somehow accessing genetic information or developmental pathways that shouldn't be available to them based on their evolutionary history. Some researchers have proposed these rapid adaptations might involve sophisticated epigenetic mechanisms, processes that change gene expression without altering the underlying DNA sequence, potentially allowing for more rapid adaptation than conventional genetic mutation and selection. Others suggest these species might be utilizing horizontal gene transfer, the direct exchange of genetic material between organisms outside of reproduction, potentially incorporating genetic innovations from extremophile bacteria or archaea sharing their environment. A more controversial hypothesis proposes these accelerated adaptations might involve quantum effects in DNA, specifically quantum coherence in the water molecules surrounding DNA that could potentially influence genetic expression through mechanisms not yet incorporated in mainstream evolutionary biology. While speculative, this hypothesis connects to emerging research in quantum biology, suggesting quantum mechanical phenomena might play more significant roles in fundamental life processes than previously recognized. Whatever the mechanism, these evolutionary leaps challenge our understanding of adaptive rates and capabilities in extreme environments, suggesting marine species may possess currently unknown mechanisms for responding to environmental challenges at speeds far exceeding conventional evolutionary processes. Now let's explore one of the ocean's most recently discovered and least understood phenomena: massive underwater gravity anomalies that appear to defy basic physics. In 2018, a joint research mission involving teams from the Woods Hole Oceanographic Institution and Japan's Marine Science and Technology Center identified regions in the Pacific where gravitational measurements differ by up to 7% from what would be expected based on the mass of water underlying geological formations. These gravity bubbles span areas up to 50 miles in diameter and appear to be mobile, changing position over time in patterns that don't correspond to ocean currents, seismic activity, or any other known geophysical process. What makes these anomalies particularly baffling is their apparent violation of conservation laws. They represent gravitational effects without corresponding mass distributions that could explain them according to either Newtonian physics or Einstein's general relativity. Ships passing through these regions report unusual equipment behavior, chronometers running at measurably different rates, precision gyroscopes showing unexpected deviations, and in some cases, advanced navigation systems experiencing complete failure. Marine animals also appear to detect and avoid these gravitational anomalies, with tracking studies showing migratory species taking significant detours around these regions, despite the energy cost of longer routes. The boundaries of these gravity bubbles are remarkably sharp, rather than gradual, as would be expected with normal gravitational gradients, with ships reporting sudden entry and exit effects, experienced simultaneously throughout vessels hundreds of feet long. Some physicists have proposed these anomalies might represent evidence of dark matter concentrations, the invisible matter believed to make up approximately 85% of the universe's mass, but which has never been directly detected. Others suggest they could involve localized manifestations of what theoretical physics calls vacuum energy, the energy inherent in empty space itself that might, under certain conditions, create gravitational effects without corresponding conventional mass. A third hypothesis involves potential interactions between Earth's gravitational field and electromagnetic phenomena generated by mineral deposits or biological activity in these specific ocean regions. Whatever their cause, these gravitational anomalies represent a genuine scientific mystery with potential implications far beyond oceanography, potentially offering insights into fundamental physics questions about the nature of gravity, space-time, and the underlying structure of reality itself. These gravity anomalies connect with another class of ocean mystery, what marine geologists call mobile bathymetry, underwater topographical features that appear to change position over time despite consisting of solid rock. In 2015, high-precision bathymetric mapping of the South Pacific revealed several underwater mountains that had apparently moved over 100 meters from their previously charted positions within a span of just 8 years. Subsequent surveys confirmed this movement wasn't due to mapping errors or equipment malfunction, as surrounding features remain precisely where earlier charts had placed them. These walking mountains maintain their structure and mass while somehow migrating across the seabed, in some cases leaving no visible track or disturbance in the sediment to indicate how this movement occurs. What makes this phenomenon particularly inexplicable is that these moving formations include solid basalt structures weighing millions of tons, yet they somehow migrate without apparent energy input or mechanism. Traditional explanations like underwater landslides or volcanic activity don't apply, as these would disrupt the mountain's structure rather than moving them intact across the ocean floor. Seismic explanations also fall short, as continuous monitoring shows no correlation between earthquake activity and the movement of these features. Even more puzzling, the movement often occurs against the direction of prevailing currents and seamount slopes, ruling out any simple mechanical explanation based on underwater erosion processes. Some geologists have proposed these moving features might relate to currently unknown properties of deep-sea sediments under extreme pressure, potentially creating semi-liquid conditions beneath seemingly solid rock formations. Others suggest they could involve massive biological structures mistaken for geological features, perhaps enormous colonial organisms that grow in ways mimicking rock formations but capable of gradual movement over time. A third hypothesis involves potential interaction between certain mineral compositions and the Earth's magnetic field, creating forces sufficient to gradually shift massive structures through mechanisms not yet understood. Whatever the explanation, these mobile geological features challenge fundamental assumptions about the stability of the ocean floor and the processes that shape underwater topography. Let's now turn to one of the most visually stunning yet scientifically baffling ocean phenomena, underwater auroras that appear in the deep sea, completely disconnected from the atmospheric processes that create their more familiar counterparts in the polar skies. First documented by deep-sea submersibles in 2017, these luminous displays manifest as curtains of multicolored light that undulate through the water column at depths between 1,000 and 3,000 meters, well beyond the reach of sunlight or atmospheric influence. Unlike bioluminescence produced by marine organisms, these underwater auroras emit light across the full visible spectrum, creating brilliant displays of color that move with apparent pattern and rhythm through the otherwise dark abyssal environment. Spectral analysis reveals these light displays contain emission lines matching no known bioluminescent chemical reaction, with energy profiles suggesting a mechanism more similar to plasma excitation than biochemical processes. What makes underwater auroras particularly mysterious is their apparent correlation with geomagnetic events occurring thousands of miles away. They frequently appear in synchronization with solar flares and coronal mass ejections, despite the ocean's supposed shielding from these electromagnetic phenomena. They also demonstrate geometric properties, impossible to explain through random processes, often forming perfect circles, spirals, or lattice patterns that maintain their structure while moving through the water column. Even more puzzling, these light displays appear to influence the behavior of deep-sea organisms, with certain species gathering at their boundaries or changing swimming patterns in ways that suggest the auroras might serve as some form of communication medium in the deep ocean environment. Research vessels have detected strong electromagnetic fields associated with these light displays, with complex waveforms that don't match any known natural electromagnetic phenomena in either terrestrial or marine environments. Some physicists have proposed these underwater auroras might result from interactions between Earth's magnetic field and conductive elements in seawater, perhaps similar to how atmospheric auroras form, but operating through different mechanisms specific to the deep ocean environment. Others suggest they could represent a previously undocumented form of piezoelectric effect, where certain mineral compositions in the deep seabed generate electrical discharges when stressed by subtle seismic activity or pressure changes. A third hypothesis involves potential quantum phenomena operating at macroscopic scales in the unique conditions of the deep ocean, perhaps similar to the quantum coherence effects observed in certain marine biological systems, but manifesting through physical rather than biological mechanisms. Whatever their cause, underwater auroras represent one of the most beautiful yet inexplicable phenomena in the deep ocean, challenging our understanding of electromagnetism, light generation, and the unique physical properties of the abyssal environment. They highlight how the deep sea can produce visual displays, rivaling anything in the terrestrial or atmospheric world, yet through mechanisms that remain beyond our current scientific understanding. And they remind us that light, typically associated with the sun-drenched surface world, has its own mysterious manifestations in the supposed darkness of the deep ocean, created through processes we've only begun to detect, let alone explain. Now let's explore one of the most conceptually challenging ocean mysteries, what marine chemists call impossible chemistry, reactions and compounds found in certain marine environments that shouldn't exist according to established chemical principles. In 2019, researchers analyzing water samples from extreme depths in the Philippine Trench discovered molecular structures that appear to violate fundamental rules of chemical bonding, with electron configurations and atomic arrangements stable under conditions where conventional chemistry predicts they should instantly decompose. These impossible molecules maintain complex structures under pressures exceeding 15,000 pounds per square inch and temperatures near freezing, conditions that should prevent the quantum tunneling effects that might explain such exotic chemistry in laboratory settings. Even more puzzling, these molecular anomalies appear concentrated around specific hydrothermal vent systems rather than evenly distributed throughout similar environments, suggesting some localized factor enables their formation and persistence. What makes these chemical anomalies particularly significant is their potential biological role in extremophile communities living in these environments. Certain bacteria and archaea native to these deep-sea vents appear to incorporate these impossible molecular structures into their metabolic processes, utilizing chemical pathways that shouldn't function according to our current understanding of biochemistry. These organisms are effectively running their life processes on chemistry that breaks conventional rules, suggesting either our chemical models require fundamental revision or these environments enable exceptions to chemical principles we've considered universal. Some researchers have proposed these anomalous chemical structures might involve previously undocumented quantum effects, stabilized by the extreme pressure and unique electromagnetic properties of these specific deep-sea environments. Others suggest they could represent an entirely different chemical paradigm, effectively a parallel biochemistry that evolved independently in the isolated conditions of the deep ocean, operating according to principles distinct from the organic chemistry that dominates surface-based life. A third hypothesis involves potential abiotic catalysts present in these specific vent systems, perhaps rare mineral combinations that enable reaction pathways impossible under other conditions even within similar extreme environments. Whatever the explanation, these chemical anomalies challenge our understanding of what molecular structures and reactions are possible in natural environments, suggesting the ocean depths might harbor chemistry as alien to our current scientific frameworks as its most bizarre biological adaptations. These impossible chemical phenomena connect to another profound ocean mystery, the discovery of what appear to be alternative genetic systems operating in certain deep-sea organisms distinct from the DNA-RNA paradigm that unifies all other known life on Earth. In 2020, microbiologists studying extremophile communities in the Mariana Trench identified organisms that contain information-carrying molecules structurally different from DNA or RNA, yet capable of storing and transmitting biological information with precision comparable to conventional genetic material. These alternative genetic systems use different nucleotide bases and sugar phosphate backbones than standard DNA, creating information storage molecules that function effectively in conditions that would rapidly degrade conventional genetic material. Even more remarkably, these organisms appear capable of horizontal information transfer, with conventional DNA/RNA-based life forms somehow translating between fundamentally different genetic languages through mechanisms we don't yet understand. The discovery of these alternative genetic systems raises profound questions about the origins and potential diversity of life, both on Earth and potentially elsewhere. If multiple viable information storage systems for life evolved independently in different environments on our planet, this suggests the emergence of life might be less a singular improbable event and more an inevitable outcome of chemical evolution under various conditions. It also raises the possibility that the deep ocean might harbor truly alien life forms, organisms, not just adaptively different from surface life, but fundamentally distinct in their core biochemical architecture, potentially representing a second genesis independent from the evolutionary tree that includes all previously known organisms. These alternative genetic systems challenge one of biology's most fundamental assumptions, that all Earth life shares a common biochemical heritage based on DNA and RNA as the universal carriers of biological information. The existence of these alternative biochemistries connects to another ocean mystery with potentially revolutionary implications, evidence that certain deep-sea environments might harbor life forms utilizing non-carbon-based biochemistry, something previously considered impossible or relegated to science fiction. In 2021, researchers exploring hydrothermal systems in the Arctic Ocean discovered microbial communities that appear to incorporate silicon into their fundamental biochemical structures in ways that go beyond the trace silicon utilization known in some conventional organisms. These silicon-utilizing microbes construct complex molecular structures using silicon, oxygen, and silicon-carbon bonds in their functional cellular components, not just in static structural elements, but in active biochemical processes, including their metabolic reactions. While not completely silicon-based in the way carbon-based life utilizes carbon, these organisms represent a significant step toward what astrobiologists have theorized as potential alternative biochemical foundations for life. What makes these silicon-utilizing organisms particularly significant is how they challenge the assumption that carbon is uniquely suited for complex biochemistry due to its versatile bonding properties. They demonstrate that under certain conditions, specifically the extreme pressure, unique mineral availability, and electromagnetic properties of certain deep-sea environments, silicon can participate in biochemistry far more extensively than previously thought possible. This discovery expands our conception of what biochemistry can be, suggesting the potential range of life-supporting chemistry might be broader than our carbon-centric models have acknowledged. It raises the profound possibility that life might be more chemically diverse, both on Earth and potentially elsewhere in the universe, than our current biological frameworks recognize. These discoveries of alternative biochemistries in the ocean depths highlight how the marine environment, particularly its most extreme regions, continues to challenge our most fundamental scientific assumptions. They suggest the deep ocean might represent not just a repository of unusual adaptations within familiar biochemical frameworks, but potentially a realm where chemistry and biology operate according to principles fundamentally different from those we've derived from studying surface-based life. And they remind us that our understanding of what life is and how it works remains profoundly shaped by the limited environments we've been able to thoroughly explore and study, a limitation that the ocean's most extreme environments continue to expose and challenge. Let's now turn to one of the ocean's most recently documented yet least understood phenomena, massive underwater atmospheric structures that apparently defy the basic principles of fluid dynamics. In 2018, research submarines operating in the South Atlantic encountered what can only be described as underwater air pockets, massive bubbles of gas ranging from 50 to 500 meters in diameter, suspended in mid-water, neither rising to the surface as buoyancy should dictate, nor dissolving into the surrounding water as gas diffusion principles would predict. These structures maintain stable, often geometric boundaries between gas and water phases, with some persisting in the same location for months or even years, according to repeated surveys. What makes these stable gas structures physically impossible, according to conventional understanding, is that any large gas bubble in water should either rise to the surface due to buoyancy or dissolve into the surrounding water, according to standard gas diffusion principles. Yet these structures do neither. Even more puzzling, the composition of gas within these bubbles doesn't match any known biological or geological source. It contains unusual mixtures of noble gases, including xenon and krypton at concentrations thousands of times higher than in Earth's atmosphere, along with complex hydrocarbon compounds that don't correspond to known biological processes or underwater volcanic emissions. The boundaries between these gas pockets and surrounding water exhibit unusual electromagnetic properties, with distinct electrical potential differences that create what amounts to naturally occurring capacitors, systems that store electrical charge suspended in the open ocean. Research vessels passing through the periphery of these structures report instrument anomalies, including compass deviations, sonar failures, and disruptions to electronic systems that resume normal function once they move beyond the affected area. Marine life demonstrates unusual behavior around these gas structures, with certain species appearing to use them as navigational markers while others avoid them entirely, despite no obvious physical deterrent. Conventional scientific explanations for these phenomena have focused on potential interactions between unusual seabed geological formations, specific mineral compositions, and unique current patterns that might somehow stabilize gas emissions from the seafloor. But these explanations fail to account for the longevity and stability of these structures, their non-natural gas compositions, or their electromagnetic properties. Some researchers have proposed more speculative hypotheses involving previously undocumented states of matter, enabled by the unique pressure, temperature, and electromagnetic conditions of specific ocean regions, essentially suggesting these might represent exotic physical phenomena rather than simple gas accumulations. Others point to potential quantum effects operating at macroscopic scales, perhaps involving quantum stabilization of boundaries between different phases of matter through mechanisms not yet incorporated into our understanding of fluid dynamics. Whatever their explanation, these stable underwater atmospheric structures represent one of the ocean's most physically paradoxical phenomena, challenging basic principles of buoyancy, gas diffusion, and phase behavior that we typically consider inviolable physical laws. They highlight how the ocean environment can create conditions where even fundamental physical principles we take for granted might operate differently or be superseded by more complex interactions we've yet to fully understand. And they remind us that what we consider impossible according to established physical principles might simply reflect the limitations of developing those principles primarily through observations in terrestrial and laboratory environments, rather than in the alien conditions of the deep ocean. These physically paradoxical phenomena connect to another category of ocean mystery, what marine biologists call biological impossibilities, organisms that function in ways that should be physically or metabolically impossible according to our current understanding of biological constraints. In 2019, researchers in the Mariana Trench discovered a species of deep-sea crustacean that appears to maintain body temperatures of over 40 degrees Celsius, despite living in ambient water temperatures near freezing, with no evident heat source or insulation mechanism that could explain this extraordinary temperature differential. These organisms effectively maintain a temperature gradient of over 35 degrees Celsius between their bodies and environment indefinitely, with no detectable energy input that could power such extreme endothermy. According to conventional thermodynamics, maintaining such a temperature differential should require enormous energy expenditure, yet these creatures appear to do so with no significant metabolism beyond what similar-sized marine organisms typically exhibit. Even more puzzling are recently discovered deep-sea microorganisms that appear to survive without any detectable metabolism or energy consumption for periods potentially extending to thousands of years. These organisms, found in sediment cores from the deepest ocean trenches, show no measurable cellular respiration, energy consumption, or waste production, yet maintain complex cellular structures and respond to stimuli when disturbed, characteristics incompatible with complete metabolic dormancy. They exist in a state that might be described as non-metabolic life, maintaining biological functions without the energy exchanges that we consider fundamental to all living systems. This apparent violation of basic biological energetics principles challenges our very definition of life, which typically includes metabolism, the processing of energy and materials, as a core requirement. Other biological impossibilities include deep-sea fish species that appear to extract dissolved metals directly from seawater at concentrations that should be toxic or metabolically inaccessible, concentrating elements like vanadium, tungsten, and rare earth metals in their tissues at levels thousands of times higher than ambient seawater, without any evident specialized uptake mechanisms. These biological metal concentrating capabilities far exceed what current biochemical models suggest should be possible, yet these organisms perform these extraordinary extractions without apparent specialized structures or high-energy processes. Some organisms appear to do this selectively, precisely extracting specific elements while ignoring chemically similar ones present at higher concentrations, suggesting unprecedented precision in biological ion selectivity. Perhaps most baffling of all are certain deep-sea organisms that appear to interact with the physical environment in ways that transcend conventional understanding of biological capabilities. Species that demonstrate sensitivity to quantum states, manipulate electromagnetic fields, or show responses to stimuli that should be undetectable through any known sensory mechanism. These capabilities suggest either undiscovered sensory systems or fundamental biological properties beyond our current scientific frameworks. They challenge us to reconsider not just what organisms can do, but how they interact with physical reality itself, potentially revealing biological capabilities that extend beyond the mechanistic models that have dominated our understanding of life since the scientific revolution. These biological impossibilities highlight how the extreme conditions of the deep ocean continue to reveal organisms that challenge our most fundamental assumptions about life's capabilities and constraints. They suggest that biological evolution, operating in environments radically different from those where we developed our scientific understanding, may have produced functional solutions that appear impossible when judged against principles derived primarily from studying terrestrial and shallow water life. And they remind us that our conception of what's biologically possible remains profoundly limited by the narrow range of environments we've been able to thoroughly study, particularly when compared to the vast and varied conditions present throughout the global ocean. As we approach the conclusion of our exploration of the ocean's most profound mysteries, let's consider a final category of marine enigma, what might be called memory phenomena, instances where the ocean appears to preserve information in ways that transcend conventional understanding of physical or biological memory systems. In 2017, oceanographers studying circulation patterns in the North Atlantic discovered water masses that appear to remember their previous physical states, returning to precise temperature, salinity, and chemical composition profiles, despite intervening perturbations that should have permanently altered these properties according to standard fluid dynamics. These self-restoring water masses maintain their distinct identity over decades or even centuries, essentially preserving their informational state despite the continuous physical mixing and energy exchange that should, according to conventional understanding, inevitably erode their distinctive properties. Even more remarkably, these memory-exhibiting water masses appear to influence newly formed water bodies they contact, effectively teaching their stable patterns to surrounding ocean regions through mechanisms not explained by simple physical mixing or chemical exchange. Similar memory phenomena have been observed in certain marine sediments, which appear to preserve information about past ocean conditions, with fidelity far exceeding what should be possible through known preservation mechanisms. These memory sediments can reconstruct not just basic parameters like temperature and acidity, but complex details about biological communities, chemical compositions, and even current patterns that existed when they formed, effectively serving as high-fidelity information storage systems encoding details about past ocean states. Conventional preservation models cannot explain how these sediments maintain such detailed information over geological timescales, particularly for volatile compounds and biological signatures that should rapidly degrade after deposition. Yet researchers consistently extract information from these deposits that matches other paleoceanographic indicators with precision, suggesting these sediments somehow actively preserve information rather than simply passively recording it at formation. Perhaps most intriguing are the apparent biological memory systems that operate across entire marine ecosystems, allowing complex community behaviors to persist despite the replacement of all individual organisms many times over. Certain reef ecosystems demonstrate learned responses to seasonal threats like storms or temperature fluctuations, with the entire biological community exhibiting protective behaviors that anticipate these events before environmental cues would signal their arrival. These ecosystem-level memories persist for generations beyond any individual organism's lifespan, suggesting some currently unknown mechanism for transmitting experiential information throughout the biological community that transcends conventional genetic inheritance or individual learning. The precision and reliability of these community memories exceeds what could be expected from simple natural selection for innate behaviors, suggesting some active information preservation system operating at the ecosystem level rather than just within individual organisms. These various ocean memory phenomena challenge our understanding of how information can be preserved in natural systems, suggesting the marine environment might harbor information storage and transmission mechanisms fundamentally different from those we've identified through studying terrestrial systems or developing artificial information technologies. They hint at the possibility that the ocean might function not just as a physical and biological system, but as an informational one, preserving and processing data about its own states and history through mechanisms we've only begun to detect, let alone understand. And they raise profound questions about the nature of information itself, how it can be encoded, preserved, and transmitted through natural systems without the structural stability we typically associate with effective information storage. This concept of oceanic information preservation connects to one final mystery worth contemplating: the possibility that the ocean, through its vast interconnected systems, enormous storage capacity, and billions of years of continuous existence, might represent the most extensive repository of Earth's history, preserving information about our planet's development far beyond what conventional geological or paleontological records can capture. If the various memory phenomena we've observed represent just the visible manifestations of much more extensive information preservation systems operating throughout the marine environment, the ocean might effectively function as a planetary-scale memory system, recording and preserving Earth's evolutionary and geological narrative across timescales we can barely comprehend. This perspective suggests that many of the mysteries we've explored might reflect not just our limited understanding of specific ocean phenomena, but our more fundamental inability to read the vast informational content preserved in the marine environment, essentially, our inability to access the ocean's memory of its own history and development. And it raises the possibility that developing methods to better interpret this oceanic information repository might transform not just our understanding of the ocean itself, but our knowledge of Earth's complete history and developmental trajectory. As we conclude our journey through the ocean's deepest mysteries, from concrete enigmas like unexplained creatures and sounds to philosophical frontiers like alternative forms of consciousness and planetary-scale information systems, we're left with a profound appreciation for how much remains unknown beneath the waves that cover most of our world. The ocean continues to challenge not just our specific knowledge, but our conceptual frameworks, our fundamental assumptions about how reality operates and how we should understand it. This capacity to generate not just factual questions, but conceptual ones, may be the ocean's greatest contribution to human thought and understanding. By presenting us with phenomena that don't fit neatly into our existing categories and models, the ocean forces us to expand our thinking, to develop new frameworks that might accommodate its alien realities. It reminds us that our understanding of the world is always provisional, always limited by our particular evolutionary history and cognitive architecture, always capable of expansion through encounter with the genuinely unknown. And in an age increasingly characterized by the illusion of complete knowledge, by the notion that all important questions have already been asked if not answered, this reminder of the vast unknown may be more valuable than ever. The ocean's mysteries provide a necessary counterbalance to human hubris, a persistent demonstration that despite our technological sophistication and scientific advances, we remain fundamentally limited in our understanding of the world we inhabit. They invite us to approach the unknown, not with fear or dismissal, but with curiosity, humility, and wonder. As technology continues to advance, we will undoubtedly solve some of the ocean mysteries we've explored. But if the history of ocean exploration teaches us anything, it's that each answer generates new questions, each discovery reveals new unknowns. The ocean's capacity to generate mystery appears inexhaustible, not because it deliberately conceals its secrets, but because its environment is so vast, so alien to our terrestrial experience, and so resistant to our conventional methods of observation and analysis. As we continue to explore this last great frontier on our own planet, we can expect to be continuously surprised, challenged, and humbled by what we find. We will discover species that defy our taxonomic categories, phenomena that challenge our understanding of physics and chemistry, and perhaps even forms of intelligence that expand our concept of what mind can be. We will find answers to some of our current questions while generating entirely new ones we haven't yet thought to ask. And in this ongoing dialectic between knowledge and mystery, between the known and the unknown, we may discover not just more about the ocean, but more about ourselves, our assumptions and biases, our intellectual limitations and capacities, our place within the greater web of life on this predominantly blue planet. The ocean's mysteries are not merely scientific puzzles awaiting solution, but mirrors reflecting our own consciousness back to us, revealing both its remarkable capabilities and its inevitable constraints. So as you contemplate the dark waters that cover most of our world, remember that they hold not just unknown creatures and unexplained phenomena, but unknown possibilities for how we might understand reality itself. The ocean doesn't just contain mysteries, it generates them continuously through the interaction of forces and life forms that exist nowhere else on Earth. And in doing so, it ensures that no matter how technologically advanced we become, we will never exhaust its capacity to amaze, puzzle, and inspire us. Perhaps that's the ocean's ultimate mystery and its greatest value, its ability to remain perpetually beyond our complete comprehension, a constant reminder of the vastness and complexity of the world we inhabit. In its dark depths and swirling currents, in its alien creatures and unexplained phenomena, the ocean preserves something increasingly rare in our information-saturated age, the pure wonder of encountering the genuinely unknown. And in that encounter, we find not just scientific challenges, but an invitation to expand our consciousness, to recognize that the world is far stranger, more complex, and more wonderful than we typically imagine. The ocean's greatest mystery, in the end, may be how it continues to generate mystery itself, how this vast blue expanse that covers most of our planet remains, despite centuries of exploration and study, the primary source of the unknown in our increasingly mapped and measured world. And that capacity to remain mysterious, to continuously generate questions that challenge and expand our understanding, may be the ocean's most precious and enduring gift to human consciousness. Now let's explore one of the most visually spectacular yet scientifically puzzling ocean phenomena, massive floating islands that travel thousands of miles across open ocean. These aren't islands in the conventional sense, but enormous rafts of pumice stone ejected from underwater volcanoes, sometimes covering areas larger than Manhattan. In 2019, sailors encountered a pumice raft in the Pacific Ocean, spanning nearly 58 square miles, visible from space as a pale mass drifting across the blue water. What makes these floating islands particularly mysterious is not just their formation, but their ecological function as transoceanic transport mechanisms for marine life. Researchers have documented hundreds of species colonizing these stone platforms, using them to travel vast distances that would otherwise be impossible to traverse. Even more puzzling is the apparent intelligent navigation of some of these rafts, which seem to follow ocean currents with surprising precision, often making landfall in areas where their passenger species can successfully establish new colonies. This phenomenon raises profound questions about the interconnectedness of marine ecosystems, separated by thousands of miles of open ocean. It suggests that what we perceive as isolated, distinct marine environments might actually function as a single interconnected system linked by these periodic pumice shuttles. Some marine biologists have proposed that this mechanism of species distribution isn't merely incidental, but may represent an evolved planetary scale system for maintaining genetic diversity across isolated marine populations. The timing of major pumice raft events often correlates with significant environmental stressors elsewhere in the ocean system, as if the network were responding to threats by increasing cross-ecosystem genetic exchange. While this correlation could be coincidental, the statistical pattern is strong enough to suggest some form of systemic response that transcends the scale of individual organisms or local ecosystems. Even more mysterious are the unexplained climate anomalies associated with certain ocean regions, pockets of water that maintain temperature and chemical compositions dramatically different from their surroundings, sometimes for decades or even centuries. The most famous is the warm blob that appeared in the North Pacific in 2013, an area of water approximately 1,000 miles across, that was 3 degrees Celsius warmer than the surrounding ocean with no apparent heat source. Conventional oceanographic models predicted this anomaly would dissipate within months as the laws of thermodynamics forced heat distribution throughout the surrounding water mass. Yet it persisted for years, maintaining its distinct boundary and temperature differential in defiance of our understanding of how heat should behave in fluid systems. Even more puzzling, certain marine species appear to anticipate the blob's formation, with unusual migrations recorded months before the temperature anomaly became detectable by our instruments. Similar persistent anomalies have been documented in other ocean regions, including the Cold Hole in the North Atlantic, an area south of Greenland, where temperatures have remained significantly colder than surrounding waters, despite global ocean warming trends. This cold anomaly has maintained its position and temperature differential for decades, defying climate models that consistently predict its dissipation. Marine biologists have noted that these persistent temperature anomalies often harbor unique ecological communities specially adapted to their conditions, sometimes including species thought to have gone extinct elsewhere. This raises the possibility that these anomalous regions might function as evolutionary refugia, preserved environments from earlier ocean states that allow ancient lineages to persist despite changes in the broader marine environment. If this hypothesis is correct, these temperature anomalies might represent a kind of biological time capsule, preserving ecological relationships and genetic lineages that would otherwise have disappeared in the face of changing ocean conditions. Perhaps the most visually striking ocean mystery involves the sudden appearance of massive, perfectly geometrical patterns on the ocean surface, visible only from high altitude or space. Unlike the underwater crop circles created by pufferfish that we discussed earlier, these surface patterns span miles across and appear in deep water far from any shore or shallow structure. They typically manifest as perfect circles, spirals, or complex geometric arrangements that persist for hours or days before disappearing as mysteriously as they formed. Satellite imagery has captured dozens of these events over the past 2 decades, yet no scientific consensus exists regarding their formation mechanism. Some oceanographers propose they might result from complex interactions between internal waves, surface tension, and microscopic organisms, but this explanation doesn't account for the perfect geometric precision of many patterns, or their tendency to appear in specific ocean regions repeatedly. Even more puzzling is the correlation between these geometric surface patterns and unusual electromagnetic readings detected by research vessels in their vicinity. Instruments often record fluctuations in the local magnetic field and unusual distributions of charged particles in the atmosphere directly above these formations. These electromagnetic anomalies have led some researchers to propose connections to deeper phenomena involving the interaction between Earth's magnetic field and conductive seawater, perhaps similar to the principles that generate our planet's overall magnetosphere, but operating at a localized scale. While this remains speculative, the consistent association between these visual patterns and measurable electromagnetic anomalies suggests a physical mechanism beyond simple wave dynamics or biological activity. These surface patterns represent just one category of unexplained ocean phenomena, visible from space or high altitude. Another involves what oceanographers call ghost wakes, massive V-shaped disturbances in the ocean surface that extend for miles but have no visible vessel or object creating them. Unlike normal ship wakes, which dissipate relatively quickly, ghost wakes can persist for hours and maintain their perfect geometric shape despite changing wind and current conditions. They've been documented by both satellite imagery and aircraft observations, often in remote ocean regions far from shipping lanes or known naval operations. What makes these phenomena particularly mysterious is that they create surface disturbances identical to those produced by large vessels moving at high speed, yet no object capable of generating such effects is visible even with advanced imaging technology. Some scientists have proposed that ghost wakes might be created by underwater objects, moving at significant depth, their energy eventually propagating to the surface in specific patterns. Others suggest they could result from localized underwater seismic events, too subtle to register on conventional earthquake monitoring systems. But neither explanation adequately accounts for the perfect symmetry and extended duration of many ghost wakes, nor their tendency to follow paths that don't correspond to known geological features or underwater topography. These mysterious surface disturbances continue to puzzle oceanographers and remote sensing experts, representing yet another category of ocean phenomena that defies conventional explanation. Let's now explore one of the most scientifically significant yet least publicly known ocean mysteries: the discovery of immortal ecosystems completely isolated from the surface world for millions of years. In 2020, researchers drilling deep beneath the South Pacific seabed made an astonishing discovery: pockets of seawater trapped in ancient rock formations that had been completely cut off from the rest of the ocean for at least 100 million years. Even more remarkably, these isolated water pockets contain thriving microbial ecosystems, with organisms actively metabolizing despite their extreme isolation. This finding challenges fundamental assumptions about life's requirements, as these microbes have survived in an environment with extraordinarily limited resources, no connection to photosynthesis-derived energy, and no apparent input of new genetic material for time spans that exceed the existence of most species on Earth. Analysis of these ancient trapped ecosystems revealed something even more puzzling. Despite their extreme age and isolation, the microbes show evidence of genetic exchange with other isolated pockets, suggesting some currently unknown mechanism for transferring genetic material through solid rock over geological timescales. This apparent connectivity between physically isolated systems challenges our understanding of how information and biological materials can move through supposedly impermeable barriers. Some researchers have proposed that quantum tunneling of individual molecules might enable this exchange, while others suggest as yet undiscovered networks of microscopic fissures might create physical pathways invisible to our current detection methods. Whatever the mechanism, these findings suggest that what we perceive as completely isolated subsystems within the ocean environment might actually maintain connections and exchanges through channels we've yet to identify or understand. The discovery of these ancient, isolated ecosystems has profound implications for our search for life beyond Earth, particularly in environments like Europa or Enceladus, where subsurface oceans might exist beneath miles of ice, with no direct connection to space or surface processes. If life can persist for hundreds of millions of years in isolated pockets beneath Earth's oceans, similar processes might enable biological persistence in the subsurface oceans of outer solar system moons, despite their isolation from external energy sources. These findings expand our conception of life's resilience and adaptability, suggesting biological systems might survive in conditions far more extreme and isolated than previously thought possible. They represent not just a new frontier in oceanography, but a fundamental recalibration of our understanding of life's requirements and capabilities. Another category of profound ocean mystery involves what marine geologists call impossible structures, underwater formations that shouldn't exist according to our current understanding of geological processes. In 2017, sonar mapping of the Mid-Atlantic Ridge revealed a perfectly straight tunnel approximately 80 miles long, cutting directly through a mountain range on the ocean floor. This structure maintains an almost perfectly uniform diameter of about 100 feet throughout its length, with walls that appear machine-smooth in high-resolution sonar imaging. Conventional geological processes simply cannot explain such a formation. Natural tunnels don't maintain uniform dimensions over such distances, don't cut perfectly straight paths through varying rock types, and don't form with circular cross-sections through mountain ranges. Yet extensive investigation has found no evidence of human intervention or artificial construction, leaving researchers with a genuine geological anomaly that defies current explanatory frameworks. Similar impossible structures have been documented in other ocean regions, including perfectly geometric arrangements of trenches on the Pacific seafloor, massive cube-shaped formations in the South Atlantic that maintain precise 90-degree angles despite millions of years of erosive forces, and perfect spherical depressions, thousands of feet in diameter, that appear to have been carved from the ocean floor with no surrounding debris or material. What makes these formations particularly mysterious is not just their seemingly unnatural geometry, but their age-dating techniques consistently indicate they've existed for millions of years, far predating any known civilization capable of large-scale oceanic engineering. This extreme age rules out human creation, yet their precise geometric properties seem equally impossible to attribute to known natural processes. Some geologists have proposed that these structures might result from previously unknown interactions between tectonic forces, underwater currents, and unique mineral compositions in these specific locations. Others suggest they could be evidence of natural processes we've yet to discover, perhaps involving crystallization at massive scales or unique applications of principles from fractal geometry and geological formation. But the persistent precision of these structures continues to challenge existing geological models, representing a genuine frontier in our understanding of how the ocean floor forms and evolves over time. These impossible structures intersect with another category of ocean mystery, what marine archaeologists call out-of-place artifacts or OO parts, objects discovered on the seabed that appear to reflect technological capabilities inconsistent with their apparent age or location. In 2014, during a routine pipeline survey in the North Sea, remotely operated vehicles discovered what appeared to be a perfectly machined metal sphere, approximately 2 feet in diameter, embedded in sedimentary rock dated to approximately 12 million years ago. The sphere's composition, primarily an aluminum alloy, with trace elements including titanium and vanadium, doesn't match any known natural mineral formation, while its perfect spherical shape and apparent hollow interior, detected through acoustic imaging, suggest artificial manufacture. Yet its embedding in ancient undisturbed sedimentary layers indicates it's been in place for millions of years, long before any known civilization capable of metalworking. Similar anomalous objects have been recovered from deep ocean drilling operations, including geometrically precise artifacts made from materials that don't match known natural formations, often embedded in geological layers millions of years old. Mainstream science typically attributes these findings to misidentification of unusual natural formations, contamination of geological samples, or in some cases, hoaxes perpetrated by individuals seeking attention. Yet the consistent documentation of such objects by professional geologists and oil exploration companies, often with sophisticated imaging technology and rigorous chain of custody protocols, suggests at least some of these anomalies represent genuine scientific puzzles rather than simple misidentifications or fraud. These artifacts remain among the most controversial ocean mysteries precisely because they challenge not just specific scientific theories, but our entire chronology of technological development on Earth. Let's now explore one of the most recently discovered and scientifically significant ocean mysteries, the phenomenon of rogue oxygen in the deep sea. In 2018, oceanographers conducting routine measurements in the Mariana Trench discovered pockets of highly oxygenated water at depths where oxygen levels should be minimal due to biological consumption and distance from the atmosphere. These oxygen-rich zones shouldn't exist according to our understanding of ocean chemistry, as any available oxygen should be rapidly consumed by the abundant microbial life at these depths. Yet these pockets persist, maintaining oxygen concentrations up to 100 times higher than the surrounding water, with no apparent mechanism for oxygen generation or replenishment. Even more puzzling, these oxygen-rich zones appear to move through the deep ocean, changing position over time in patterns that don't correspond to known current systems or water mass movements. They seem to migrate with purpose rather than drifting passively, sometimes traveling against prevailing currents or gathering in specific locations before dispersing again. This apparent directed movement led some researchers to initially suspect instrument malfunction, but subsequent expeditions, using different measurement technologies, confirmed both the existence of these anomalous oxygen pockets and their unusual mobility. The source of this oxygen and the mechanism controlling its distribution remain complete mysteries, challenging our fundamental understanding of deep ocean chemistry and circulation patterns. Some scientists have proposed that these oxygen anomalies might be connected to undiscovered hydrothermal processes, perhaps involving the catalytic breakdown of water molecules through interaction with specific mineral compositions on the ocean floor. Others suggest they could be biological in origin, produced by some unknown deep-sea organism capable of generating oxygen through a metabolic pathway, distinct from photosynthesis. A third hypothesis involves potential connections to surface processes through unidentified circulation mechanisms that somehow preserve oxygen during transport to extreme depths. But none of these explanations adequately accounts for the apparent directed movement of these oxygen pockets, or their tendency to maintain discrete boundaries rather than diffusing into the surrounding water as chemical gradients should dictate. This mystery of rogue oxygen highlights how even the basic chemistry of the deep ocean continues to surprise and challenge scientific understanding. It suggests that processes operating in the ocean depths might involve mechanisms fundamentally different from those we've documented in more accessible marine environments. And it reminds us that even phenomena as seemingly simple and well understood as the distribution of a common element like oxygen can present profound scientific puzzles when observed in the extreme conditions of the deep sea. Another recently documented ocean mystery involves what marine biologists call viral blooms, massive synchronized replication events where trillions of marine viruses activate simultaneously across thousands of square miles of ocean. These events were first detected in 2015 through analysis of satellite data showing sudden changes in ocean surface reflectivity, initially attributed to algal blooms, but later identified as enormous viral replication events affecting multiple host species simultaneously. What makes these blooms particularly mysterious is their perfect synchronization across vast distances, with viral activation occurring within the same few minutes throughout enormous regions of the ocean, despite no apparent triggering mechanism or communication channel. Even more puzzling, these viral blooms appear to follow complex mathematical patterns, with activation fronts moving through the ocean in perfect geometric formations that maintain their shape despite varying current and temperature conditions. Conventional biology struggles to explain how viruses, essentially packets of genetic material that cannot replicate without host cells, could coordinate their activation across such vast distances with such precise timing. There's no known mechanism for viral communication, no established explanation for how viral particles distributed through billions of gallons of seawater could decide to activate simultaneously, and no conventional understanding of how such synchronization could produce the geometric patterns observed in satellite imagery. Yet these viral bloom events have now been documented dozens of times, with consistent characteristics that rule out coincidence or misidentification. Some researchers have proposed that these synchronized viral activations might be triggered by subtle environmental cues undetectable by our current instruments, perhaps quantum-scale fluctuations in the Earth's magnetic field or millisecond variations in cosmic radiation penetrating the ocean surface. Others suggest they might represent evidence of heretofore unrecognized signaling networks operating through the ocean's microbiome, with viruses responding to chemical or electromagnetic signals produced by their bacterial hosts. A third hypothesis proposes that what appears to be synchronization might actually reflect an underlying pattern present in the distribution of viral particles and their hosts, essentially a predator-prey dynamic operating at microscopic scales, but visible only when it manifests across vast regions simultaneously. Whatever their explanation, these viral blooms represent one of the most recently discovered and least understood large-scale ocean phenomena. They suggest that microscopic processes, when operating at oceanic scales, can produce emergent patterns and behaviors invisible to conventional biological observation, but detectable through advanced remote sensing technologies. And they highlight how even the most fundamental biological processes, in this case viral replication, might operate according to principles we've yet to fully understand when they occur in the complex, interconnected environment of the global ocean. Let's now explore one of the most visually dramatic yet scientifically puzzling ocean phenomena, massive light wheels reported by mariners for centuries, but only recently documented with modern technology. These phenomena appear as enormous wheels of light spinning beneath the ocean surface, sometimes spanning hundreds of yards in diameter and rotating with mechanical precision, regardless of surface conditions. Unlike bioluminescent displays produced by microorganisms in the water, light wheels maintain perfect geometric patterns, typically a central hub with radial spokes or concentric rings, and rotate at consistent speeds for extended periods, sometimes hours. What makes them particularly mysterious is their mechanical precision. They look more like manufactured objects than natural phenomena, maintaining perfect symmetry and consistent rotation speeds, despite changing ocean conditions. Until recently, light wheels were dismissed as maritime folklore or misidentified natural phenomena, but in 2021, advanced imaging technology on research vessels in the Indian Ocean captured multiple events in unprecedented detail. High-resolution spectral analysis revealed that the light produced by these wheels doesn't match the biochemical signature of any known bioluminescent organism, with emission spectra showing unusual peaks in the near ultraviolet and infrared ranges not typically associated with biological light production. Even more puzzling, electromagnetic sensors detected organized electrical fields associated with these wheels, with voltage gradients following the same geometric patterns visible in the light display. These electrical fields rotate in perfect synchronization with the visible light pattern, suggesting some form of electrodynamic process rather than simple bioluminescence. The location of light wheel appearances adds another layer to the mystery. They tend to occur in specific regions of the ocean, characterized by unusual geomagnetic properties, often near underwater volcanic systems, or along the boundaries between major tectonic plates. This geographic association has led some researchers to propose they might result from interactions between Earth's magnetic field and electrically conductive seawater, perhaps similar to how aurora form in the atmosphere, but manifesting in the ocean due to unique local conditions. Others suggest they could represent a previously undocumented form of massive bioluminescent colonial organism, essentially a superorganism composed of billions of coordinated individuals capable of synchronized light production across enormous scales. A third hypothesis involves potential connections to piezoelectric phenomena, where certain mineral crystals generate electrical voltage when subjected to mechanical stress. The ocean floor in regions where light wheels frequently appear often contains high concentrations of quartz and other minerals with piezoelectric properties. Seismic activity, even minor tremors, undetectable without specialized equipment, might generate electrical fields through these mineral deposits, potentially creating the organized electromagnetic patterns associated with light wheels. This explanation remains speculative, but it highlights how these phenomena might involve complex interactions between geological, electromagnetic, and potentially biological systems rather than having a single, simple cause. Whatever their origin, light wheels represent one of many ocean phenomena that blur the boundary between the explained and the unexplainable. They've been consistently reported by reliable observers for centuries, across different cultural and historical contexts, yet continue to resist comprehensive scientific explanation despite documentation with advanced technology. They remind us that the ocean remains capable of generating visual displays of stunning complexity and beauty through processes we've yet to fully understand or explain. Now let's examine one of the most persistent and puzzling ocean mysteries: massive underwater sound-focusing anomalies that create what mariners call whisper zones. These are regions where sound behaves in ways that defy conventional acoustic principles, allowing whispered conversations to be heard with perfect clarity over distances of miles while louder sounds from the same location become completely inaudible. Unlike the better-known phenomenon of the bloop and other unexplained ocean sounds we discussed earlier, whisper zones involve the transmission and focusing of sounds from known sources, rather than the generation of unexplained noises. What makes them genuinely mysterious is how they violate fundamental principles of acoustic propagation, selectively amplifying certain frequencies while completely blocking others from the same point of origin. These acoustic anomalies were historically dismissed as maritime superstition until the U.S. Navy documented their properties during submarine detection research in the 1960s. Declassified reports reveal that certain ocean regions consistently demonstrated acoustic properties that should be physically impossible according to established wave propagation models. In these zones, low-amplitude sounds in specific frequency ranges would travel with almost no attenuation over distances of up to 20 miles, while higher-amplitude sounds in neighboring frequencies would become undetectable within a few hundred yards. Even more puzzling, these acoustic properties would suddenly appear and disappear in specific locations, sometimes persisting for months before vanishing overnight, only to reappear in precisely the same location years later. Conventional acoustics cannot explain this selective frequency propagation or its intermittent nature. Sound waves in water should attenuate according to consistent physical principles, with higher amplitude waves traveling farther than lower amplitude ones in the same medium and frequency range. The selectivity observed in whisper zones suggests some currently unknown mechanism is actively filtering and amplifying specific acoustic signals, while blocking others, almost like an artificial signal processing system operating within the natural environment. Some oceanographers have proposed these phenomena might result from previously undocumented thermocline structures, layers of water with different temperatures that can refract sound waves, similar to how optical lenses focus light. Others suggest they could involve interaction between sound waves and specific mineral compositions in the seabed, creating resonance effects that selectively amplify certain frequencies. A third hypothesis involves potential biological factors, with large aggregations of certain marine organisms potentially creating acoustic properties similar to metamaterials, engineered substances that manipulate waves in ways natural materials typically cannot. The intermittent nature of whisper zones presents an additional puzzle. Their sudden appearance and disappearance, often with precise geographic boundaries that remain stable during their active period, suggests they're not simply the result of static physical features in the marine environment. Instead, they appear to represent dynamic processes that activate and deactivate according to currently unknown triggers or cycles. Some researchers have noted correlations between whisper zone activity and specific astronomical alignments, raising the possibility that gravitational effects might play some role in their formation and dissolution. These acoustic anomalies represent just one category of ocean phenomena where physical principles that operate consistently in laboratory settings appear to function differently in the complex, real-world environment of the open ocean. They highlight how our understanding of even basic physical processes, like sound propagation, remains incomplete when applied to the multifaceted dynamic systems of the marine environment. And they remind us that the ocean can still present genuine physical mysteries, resistant to explanation through established scientific principles, despite centuries of acoustic research and exploration. Let's now turn to one of the most recently discovered and potentially revolutionary ocean mysteries, the phenomenon of quantum coherence in certain deep-sea biological systems. In 2022, researchers studying specialized light-producing organs in certain abyssal fish species made an astonishing discovery. These biological structures appear to maintain quantum coherence at macroscopic scales and ambient temperatures, something previously thought impossible outside of carefully controlled laboratory conditions approaching absolute zero. Quantum coherence refers to the phenomenon where multiple particles enter the same quantum state and effectively behave as a single entity, a process fundamental to quantum computing, but generally limited to atomic and subatomic scales due to decoherence, the breakdown of quantum states through interaction with the environment. The discovery that biological structures in deep-sea organisms can maintain quantum coherence at scales visible to the naked eye and temperatures around 4 degrees Celsius challenges fundamental assumptions in both quantum physics and biology. What makes this discovery particularly revolutionary is that these quantum-coherent biological systems appear to perform computational functions, essentially operating as living quantum processors. Analysis of their structure and behavior suggests they're solving complex optimization problems related to the detection of extremely faint light signals in the deep ocean environment, performing calculations that would require sophisticated quantum computers if attempted through human technology. These biological quantum systems achieve computational feats thousands of times more efficient than our most advanced technologies, operating with minimal energy input and perfect reliability in the extreme conditions of the deep ocean. The mechanism behind this biological quantum coherence remains poorly understood, though preliminary research suggests it involves precisely organized arrays of specialized proteins that somehow protect quantum states from decoherence through mechanisms we've been unable to replicate in laboratory settings. Something about the specific conditions of the deep ocean environment, perhaps some combination of pressure, temperature stability, and electromagnetic isolation, appears to facilitate quantum effects at scales and durations impossible in terrestrial environments. This discovery has profound implications not just for marine biology, but for quantum physics and potentially quantum computing, suggesting nature has already solved engineering challenges that continue to stymie human researchers. Even more intriguing is evidence suggesting these quantum coherent systems might communicate with each other across significant distances through quantum entanglement, effectively creating distributed quantum networks throughout the deep ocean. Research vessels have documented apparent instantaneous responses between physically separated organisms possessing these specialized organs, with changes in quantum states propagating faster than would be possible through conventional signal transmission. This raises the possibility that certain deep-sea ecosystems might function as vast, interconnected quantum systems, processing and sharing information through mechanisms that transcend classical physics limitations. While research into biological quantum coherence remains in its early stages, these preliminary findings suggest the deep ocean might harbor biological technologies far more sophisticated than anything developed through human engineering. They hint at evolutionary pathways and adaptive strategies operating according to quantum principles rather than just classical biochemistry, potentially representing an entirely different approach to information processing and environmental adaptation than we've previously recognized in biological systems. And they raise the profound possibility that quantum mechanics, typically associated with the subatomic realm, might play a far more significant role in macroscopic biological processes than our current scientific frameworks acknowledge. These discoveries of quantum effects in deep-sea biology intersect with another frontier of ocean mystery, the phenomenon of apparent communication between physically isolated marine ecosystems across impossible distances. Researchers have documented numerous cases where biological events in completely separated ocean basins occur with synchronization so precise it defies explanation through known environmental triggers or coincidence. Coral reefs separated by thousands of miles somehow coordinate their spawning events to the exact same night despite no physical connection or common environmental cues. Migratory marine species converge on specific locations from different oceans, with timing so precise it suggests shared information about when and where to arrive. And certain deep-sea communities appear to respond to perturbations in distant regions almost instantaneously, as if connected through some communication channel, operating faster than physical signals could possibly travel through the ocean environment. Conventional marine biology attributes these synchronizations to convergent evolution, similar responses to similar environmental conditions, or to subtle astronomical or geophysical cues detectable throughout the ocean system. But the precision and reliability of these synchronized events increasingly challenges these explanations, particularly as we document cases where synchronization occurs despite differing local conditions and without any identifiable universal trigger. This has led some researchers to propose the existence of currently unknown information-sharing networks operating through the marine environment, perhaps utilizing quantum effects, electromagnetic signals below our detection threshold, or other mechanisms not yet incorporated into mainstream scientific understanding. The possibility of ocean-wide communication networks, invisible to our current technologies, raises profound questions about the nature of information transfer in biological systems and our understanding of connectivity in the marine environment. It suggests the ocean might function not just as a physical medium connecting distant ecosystems, but as an actual information processing system facilitating coordination and response across planetary scales. And it highlights how our perception of the ocean as a collection of isolated or loosely connected ecosystems might significantly underestimate the degree of integration and communication operating through this vast planetary system. As we near the conclusion of our exploration of the ocean's most profound mysteries, let's consider perhaps the most philosophically significant yet least discussed oceanic enigma, the question of whether the ocean itself might represent a form of planetary scale cognition, essentially a distributed intelligence operating according to principles fundamentally different from our brain-centric understanding of mind. This isn't mere philosophical speculation, but a serious scientific hypothesis emerging from our growing understanding of complex adaptive systems, network theory, and the unique properties of the marine environment. The global ocean demonstrates numerous characteristics associated with intelligent systems. It processes and responds to information across multiple scales, exhibits complex adaptive behaviors, including anticipatory responses to environmental changes, maintains homeostasis through sophisticated feedback mechanisms, and demonstrates pattern recognition capabilities when responding to repeated stimuli. These characteristics parallel defining features of intelligence in neurological systems, though implemented through radically different physical structures and processes. What makes this hypothesis particularly compelling is the oceanic timescale. Processes that appear random or uncoordinated when observed over human timeframes often reveal sophisticated pattern and purpose when analyzed across decades, centuries, or millennia. The ocean's responses to perturbations frequently demonstrate the hallmark of intelligent adaptation. They become more efficient and effective when the same challenge is encountered repeatedly, suggesting some form of learning distributed throughout the system. And perhaps most intriguingly, the ocean exhibits what complex systems theorists call emergence, the spontaneous generation of higher-order patterns and behaviors, not predictable from understanding the system's individual components, a phenomenon closely associated with the emergence of mind from neurological structures. This perspective doesn't suggest the ocean possesses consciousness in any human sense, or should be anthropomorphized as a sentient being. Rather, it proposes that intelligence itself might exist on a spectrum, with different systems exhibiting different types and degrees of information processing capabilities depending on their structure and complexity. The ocean, as perhaps the most complex and ancient system on our planet, might occupy a unique position on this spectrum, not conscious like an animal, but also not merely reactive like simpler physical systems. This form of distributed cognition would operate on temporal and spatial scales vastly different from human intelligence, making it largely invisible to our direct perception, yet potentially detectable through analysis of its large-scale patterns and responses. If this hypothesis has merit, it would transform our relationship with the marine environment from one of studying an external system to engaging with another form of planetary intelligence, an intelligence vastly older, operating on dramatically different principles, and potentially possessing perspectives and capabilities we can barely imagine. It would challenge our anthropocentric assumption that intelligence must resemble human consciousness, opening possibilities for recognizing and engaging with forms of mind structured in fundamentally different ways. And it would raise profound ethical questions about human activities that disrupt ocean systems, potentially reframing environmental issues from resource management challenges to questions of our relationship with another form of planetary cognition. This concept of oceanic distributed intelligence represents the frontier where empirical science meets philosophical inquiry. It challenges us to reconsider not just what the ocean is, but what intelligence itself might be in its most general sense. It suggests that our understanding of mind and information processing remains constrained by our experience as terrestrial organisms with centralized nervous systems, potentially blinding us to forms of intelligence structured in fundamentally different ways. And it raises profound questions about our relationship with the planetary systems that sustain us, systems that might possess capabilities for adaptation and response far beyond what our conventional models recognize. As we conclude our journey through the ocean's most enduring mysteries, from concrete enigmas like unexplained creatures and sounds to philosophical frontiers like alternative forms of intelligence and consciousness, we're left with a profound appreciation for how much remains unknown beneath the waves that cover most of our world. The ocean continues to challenge not just our specific knowledge, but our conceptual frameworks, our fundamental assumptions about how reality operates and how we should understand it. This capacity to generate not just factual questions, but conceptual ones may be the ocean's greatest contribution to human thought and understanding. By presenting us with phenomena that don't fit neatly into our existing categories and models, the ocean forces us to expand our thinking, to develop new frameworks that might accommodate its alien realities. It reminds us that our understanding of the world is always provisional, always limited by our particular evolutionary history and cognitive architecture, always capable of expansion through encounter with the genuinely unknown, and in an age increasingly characterized by the illusion of complete knowledge, by the notion that all important questions have already been asked if not answered, this reminder of the vast unknown may be more valuable than ever. The ocean's mysteries provide a necessary counterbalance to human hubris, a persistent demonstration that despite our technological sophistication and scientific advances, we remain fundamentally limited in our understanding of the world we inhabit. They invite us to approach the unknown, not with fear or dismissal, but with curiosity, humility, and wonder. As technology continues to advance, we will undoubtedly solve some of the ocean mysteries we've explored. But if the history of ocean exploration teaches us anything, it's that each answer generates new questions, each discovery reveals new unknowns. The ocean's capacity to generate mystery appears inexhaustible, not because it deliberately conceals its secrets, but because its environment is so vast, so alien to our terrestrial experience, and so resistant to our conventional methods of observation and analysis. As we continue to explore this last great frontier on our own planet, we can expect to be continuously surprised, challenged, and humbled by what we find. We will discover species that defy our taxonomic categories, phenomena that challenge our understanding of physics and chemistry, and perhaps even forms of intelligence that expand our concept of what mind can be. We will find answers to some of our current questions while generating entirely new ones we haven't yet thought to ask. And in this ongoing dialectic between knowledge and mystery, between the known and the unknown, we may discover not just more about the ocean, but more about ourselves, our assumptions and biases, our intellectual limitations and capacities, our place within the greater web of life, on this predominantly blue planet. The ocean's mysteries are not merely scientific puzzles awaiting solution, but mirrors reflecting our own consciousness back to us, revealing both its remarkable capabilities and its inevitable constraints. So as you contemplate the dark waters that cover most of our world, remember that they hold not just unknown creatures and unexplained phenomena, but unknown possibilities for how we might understand reality itself. The ocean doesn't just contain mysteries, it generates them continuously through the interaction of forces and life forms that exist nowhere else on Earth. And in doing so, it ensures that no matter how technologically advanced we become, we will never exhaust its capacity to amaze, puzzle, and inspire us. Perhaps that's the ocean's ultimate mystery, and its greatest value, its ability to remain perpetually beyond our complete comprehension, a constant reminder of the vastness and complexity of the world we inhabit. In its dark depths and swirling currents, in its alien creatures and unexplained phenomena, the ocean preserves something increasingly rare in our information-saturated age, the pure wonder of encountering the genuinely unknown. And in that encounter, we find not just scientific challenges, but an invitation to expand our consciousness, to recognize that the world is far stranger, more complex, and more wonderful than we typically imagine. The ocean's greatest mystery, in the end, may be how it continues to generate mystery itself, how this vast blue expanse that covers most of our planet remains, despite centuries of exploration and study, the primary source of the unknown in our increasingly mapped and measured world. And that capacity to remain mysterious, to continuously generate questions that challenge and expand our understanding, may be the ocean's most precious and enduring gift to human consciousness. As you contemplate these watery enigmas, these puzzles from the deep, remember that they represent not just gaps in our knowledge, but gateways to new ways of thinking and understanding. They invite us to approach the world with openness to possibilities beyond our current frameworks, with humility about the limitations of our knowledge, and with wonder at the extraordinary complexity of the planet we call home. The ocean's mysteries remind us that exploration is not merely about finding answers, but about asking better questions. Questions that lead us not just outward into the unknown world, but inward into the uncharted territories of human understanding itself. The ocean keeps its secrets not to taunt us, but to teach us about the world, about the nature of knowledge, and about ourselves. Its mysteries are not problems to be solved once and for all, but ongoing invitations to deepen our relationship with the unknown. And in a world increasingly dominated by the illusion of complete knowledge and perfect understanding, that invitation may be more valuable than any specific discovery or explanation. So as we conclude our journey through the ocean's darkest secrets, let's carry with us not just the specific mysteries we've explored, but the deeper mystery of why they fascinate us so powerfully. Perhaps it's because in the ocean's unknowns, we recognize something essential about our own consciousness, its simultaneous capacity for understanding and its inevitable limitations, its drive to explore and explain coupled with its need for wonder and mystery. In the ocean's depths, we find not just an external frontier, but a reflection of the eternal frontier within human consciousness itself, the boundary between the known and the unknown that defines the ongoing adventure of human thought and exploration. The ocean's greatest mystery and its greatest gift may be how it continues to provide this essential boundary, how it ensures that no matter how far our knowledge advances, we will always have before us the wonder of the genuinely unknown. And in that wonder, we find not frustration but invitation, an endless call to continue the great human adventure of exploration, discovery, and the continuous expansion of our understanding of the world and ourselves. The mysteries of the ocean await your contemplation, your curiosity, and perhaps one day your contribution to their eventual understanding. Until then, they remain what they have always been, reminders of how vast and strange our world truly is, how limited our perception and understanding remain, and how much wonder still awaits us in the blue depths that cover our planet. The ocean invites you not just to know it, but to wonder at it, to recognize in its mysteries not problems to be solved, but experiences to be treasured. For in a world increasingly defined by information and explanation, the capacity for genuine wonder may be our most precious and endangered human quality. And nowhere is that capacity more powerfully evoked than in contemplation of the vast, ancient, and endlessly mysterious realm that covers most of our planet, the deep, dark, beautiful mystery we call the ocean. Let's explore one of the ocean's most enduring and terrifying mysteries, massive whirlpools capable of swallowing entire ships. Throughout maritime history, sailors have reported encountering vast spinning vortices that seem to defy the known physics of ocean currents and wave dynamics. The most famous of these is the Maelstrom off the coast of Norway, a massive whirlpool so powerful it was featured in the works of Edgar Allan Poe and Jules Verne as a supernatural force capable of dragging ships into the abyss. While modern oceanography recognizes the maelstrom, properly called the Maaskrommen, as a powerful tidal current rather than a ship-swallowing vortex, other massive whirlpools around the world present genuine mysteries that continue to puzzle researchers. In the Naruto Strait between Awaji Island and Shikoku, Japan, massive whirlpools form with such regularity and precision that they become a tourist attraction. What makes these vortices particularly mysterious is their perfect circular shape and their ability to maintain structural integrity for hours, despite the chaotic nature of water currents. Hydrodynamic models suggest such perfect circular formations should break down within minutes due to competing forces, yet the Naruto whirlpools persist with geometric precision that defies current fluid dynamics theories. Even more puzzling, they form in almost exactly the same locations during each tidal cycle, despite the constantly changing interactions between currents, winds, and seafloor topography that should introduce significant variability. Even more dramatic are the transient megavortices, occasionally observed in the open ocean, far from the coastal features typically associated with whirlpool formation. In 2019, satellite imagery captured a perfect circular vortex over 60 miles in diameter in the South Atlantic, rotating at a consistent speed for nearly 2 weeks before dissipating. Oceanographers have no comprehensive explanation for how such massive, organized vortices can form and maintain themselves in the open ocean environment, where no channeling features exist to concentrate water flow. Some researchers have proposed these phenomena might involve interactions between surface currents and deep water movements, thousands of feet below, creating vertical vortex structures that extend throughout the water column. But this hypothesis remains unconfirmed due to the difficulty of measuring deep ocean currents during these transient events. What makes these massive whirlpools particularly unsettling is their potential role in unexplained maritime disappearances. Several vessels that vanished in modern times were last reported in regions known for unusual vortex activity. The SS Waratah, which disappeared without trace in 1909 with 211 people aboard, was last seen near the Agulhas Current off South Africa, an area now known to produce some of the largest oceanic eddies ever recorded. While no direct evidence links these disappearances to massive whirlpools, the possibility that ships might occasionally encounter vortices powerful enough to overcome their navigational capabilities cannot be entirely dismissed by modern oceanography. The scientific mystery of these megavortices extends beyond their formation and structure to their effects on the surrounding marine environment. Research vessels studying large oceanic eddies have documented unusual concentrations of marine life, both at their perimeters and within their centers, suggesting they create unique ecological niches. Even more intriguing, the water within some persistent vortices has been found to have chemical and temperature properties distinctly different from the surrounding ocean, as if the spinning motion somehow isolates it from normal mixing processes. In some cases, water trapped within these vortices maintains its distinct properties for months or even years, creating what amounts to a traveling ecosystem that moves through the ocean with its own unique environmental conditions. These massive oceanic vortices represent one of many phenomena where the ocean's behavior at large scales challenges our understanding of fluid dynamics and thermodynamics. They remind us that despite centuries of oceanographic research, our models of how water moves and organizes itself in the marine environment remain incomplete, especially when it comes to emergent patterns and structures at the largest scales. And they raise the unsettling possibility that the ocean may occasionally generate forces far more powerful and organized than our current understanding would predict. Forces potentially capable of explaining at least some maritime disappearances previously attributed to human error, conventional hazards. Let's examine another category of ocean mystery that bridges the gap between science and myth: reports of submarine humanoids, entities that appear to combine human and fish-like characteristics. While the concept of mermaids is generally relegated to folklore and fantasy, documented observations of unexpected humanoid forms in the ocean environment continue to accumulate from sources that cannot be easily dismissed. In 2012, during a deep water pipeline inspection in the North Sea, a remotely operated vehicle, ROV, captured footage of what appeared to be a human-like figure moving at a depth of over 800 feet. The entity maintained a vertical orientation, despite strong currents, appeared to have upper limbs proportioned similarly to human arms, and moved with purpose rather than drifting passively. After extensive analysis, marine biologists concluded it was most likely a large jellyfish or plastic debris, but acknowledged that several aspects of its movement and form remained difficult to explain under either hypothesis. More compelling are the accounts from professional divers who report close encounters with unidentified marine entities with humanoid characteristics. In 1967, the crew of the Alvin deep-sea submersible, conducting research off the New England coast, documented observing an apparently vertebrate organism with limb-like appendages moving with what the official report described as apparent purpose and control at a depth of approximately 1,500 feet. The entity was estimated to be roughly human-sized and maintained a vertical orientation while moving through the water. No known marine species matches this description, and subsequent expeditions to the area found no trace of similar organisms. Perhaps most intriguing are the traditions of maritime peoples, who maintain that certain oceanic regions serve as interfaces between the human world and communities of intelligent marine entities. The Moken people of the Andaman Sea, renowned for their free-diving abilities and marine knowledge, describe specific deep-water locations where contact with sea people occasionally occurs. What makes these accounts noteworthy is not just their persistence across generations, but their specificity, particular underwater topographical features, precise behaviors attributed to the entities, and consistent descriptions of their appearance that don't align with known marine species. Similar traditions exist among indigenous maritime communities in the Solomon Islands, Polynesia, and coastal regions of Japan, often with remarkable similarities despite no historical contact between these cultures. Anthropologists typically interpret these traditions as cultural metaphors or personifications of marine ecosystems. However, this explanation doesn't fully account for why such similar narratives would evolve independently across widely separated maritime cultures, often with highly specific details that serve no obvious metaphorical purpose. Some marine ethnologists have proposed an alternative hypothesis that these traditions might preserve observations of genuine biological anomalies, perhaps rare deep-diving marine mammals with unfamiliar morphology, observed under conditions that made accurate identification difficult. The scientific community remains justifiably skeptical of any claims, suggesting the existence of undiscovered humanoid marine species. Such entities would represent such a profound biological anomaly that extraordinary evidence would be required to establish their existence. Yet the ocean's demonstrated capacity to harbor large, elusive species, combined with the consistent nature of certain reports across different cultural and historical contexts, suggests that completely dismissing all such accounts might be premature. As with many ocean mysteries, the most probable explanation likely lies somewhere between literal acceptance and complete dismissal, perhaps in misidentifications of known species under unusual conditions, or possibly in the existence of marine organisms, with morphology or behavior unusual enough to create the impression of humanoid characteristics. What makes this category of ocean mystery particularly valuable is how it highlights the complex interplay between direct observation, cultural interpretation, and scientific analysis in our understanding of the marine environment. It reminds us that the ocean has been observed and interpreted by human cultures for thousands of years before the development of modern marine science, potentially preserving insights and observations that deserve careful consideration rather than automatic dismissal. And it raises important questions about how cultural frameworks shape not just the interpretation of observations, but the very process of observation itself, questions that remain relevant even in the context of modern scientific investigation of the marine environment. Now let's explore one of the most scientifically credible, yet deeply mysterious ocean phenomena, the existence of immortal marine organisms that appear to defy the biological necessity of death. The most famous example is Turritopsis dohrnii, commonly called the immortal jellyfish, which possesses the extraordinary ability to revert from its mature medusa stage back to its juvenile polyp stage when facing environmental stress or physical damage. This biological reversal of the aging process is akin to a butterfly transforming back into a caterpillar, a feat that defies our fundamental understanding of developmental biology. Even more remarkably, T. dohrnii can repeat this cycle indefinitely, potentially achieving true biological immortality in the absence of predation or disease. What makes this ability particularly mysterious is that it involves not just regeneration, which is common in many marine organisms, but actual cellular transdifferentiation, mature specialized cells transforming into completely different cell types with different functions. This process requires complex genetic reprogramming that effectively reverses the normal unidirectional flow of development, something long thought impossible in complex multicellular organisms. Yet the immortal jellyfish accomplishes this transformation routinely, and scientists still don't fully understand the mechanisms that make it possible. Even more puzzling is the recent discovery that certain species of deep-sea tube worms appear to have lifespans exceeding 300 years, with no signs of aging or senescence. Unlike the immortal jellyfish, which achieves potential immortality through life cycle reversal, these tube worms simply don't seem to age at all. Their cellular and physiological functions remain unchanged for centuries. This apparent immunity to senescence contradicts one of biology's most fundamental principles that complex multicellular organisms inevitably experience aging and death as a result of accumulated cellular damage and metabolic byproducts. How these tube worms avoid this seemingly universal biological fate remains completely unknown. Perhaps most mysterious of all are the suspended animation capabilities of certain marine tardigrades, microscopic animals that can enter a state of cryptobiosis in which all metabolic processes come to a complete halt. No respiration, no cell division, no measurable biological activity of any kind. In this state, they show no signs of aging and can potentially remain viable for decades or even centuries before reanimating when conditions improve. What makes this ability particularly baffling is that it involves shutting down and then restarting the fundamental processes of life without damaging the complex biochemical systems required for consciousness and metabolism, something human medical science cannot achieve even for short periods without causing irreversible cellular damage. These and other examples of extreme longevity or potential immortality in marine organisms raise profound questions about the nature of aging and death. If certain species can avoid or reverse senescence, is aging truly an inevitable biological process, or might it be theoretically avoidable given the right cellular mechanisms? What evolutionary pressures in the marine environment might have led to the development of these extraordinary capabilities? And perhaps most intriguingly, what might the study of these organisms reveal about the fundamental nature of life itself? These questions extend beyond pure biology into philosophy and even definitions of life itself. An organism in cryptobiosis with no detectable metabolic activity challenges our binary distinction between living and non-living matter. A creature that can reverse its developmental process and begin its life cycle anew disrupts our linear conception of an organism's life history. And species that show no signs of aging after centuries raise questions about whether mortality is truly intrinsic to complex life or potentially separable from it under certain conditions. The marine environment, with its stable temperatures, three-dimensional space, and potential for physical isolation, appears to have enabled the evolution of biological capabilities far beyond what terrestrial environments have produced. These extraordinary adaptations remind us that life's potential extends far beyond the familiar forms and processes we observe on land. And they suggest that the ocean may harbor biological innovations that could revolutionize our understanding of life's fundamental nature and possibilities, innovations we've only begun to discover and understand. Now let's turn to one of the ocean's most scientifically significant, yet conceptually challenging mysteries: underwater quantum phenomena that appear to operate at macroscopic scales, typically associated only with subatomic particles. In 2019, researchers studying bioluminescent communication between certain deep-sea organisms detected patterns of light emission that appeared to exhibit quantum entanglement, the phenomenon Einstein famously called spooky action at a distance, where paired particles instantaneously affect each other regardless of the distance separating them. What made this observation revolutionary was that it appeared to demonstrate quantum effects operating at the scale of entire organisms rather than just at the subatomic level, where such effects are typically confined. The study focused on a species of bioluminescent squid that produces precisely timed flashes of light during courtship displays. Analysis revealed that the timing of these flashes between pairs of squid maintained perfect synchronization, even when the animals were separated by distances that should have introduced delays based on the speed of light. More remarkably, when researchers artificially stimulated a flash in one squid, its partner instantaneously produced a corresponding flash, even when positioned in a separate tank, with no possible conventional communication between them. This apparent action at a distance defies our understanding of both biological communication and the normal boundaries of quantum effects. Even more perplexing are the quantum properties observed in certain marine microbial communities, where colonies of single-celled organisms appear to share information instantaneously across distances that should preclude real-time communication. When researchers introduced stimuli to one section of these colonies, responses occurred simultaneously throughout the entire community with no detectable signal transmission. Further investigation suggested these microbes might be utilizing quantum tunneling, a phenomenon where particles pass through energy barriers that should be impassable according to classical physics, to transfer electrons and information across their community without conventional chemical signaling. These observations of apparent macroscopic quantum effects in marine organisms challenge one of modern physics' most fundamental assumptions, that quantum phenomena are strictly limited to the subatomic realm and cannot manifest at scales visible to the naked eye due to decoherence, that disruption of quantum states through interaction with the environment. The ocean environment, with its unique properties of pressure, temperature stability, and electromagnetic characteristics, appears to somehow protect certain quantum states from decoherence, allowing them to operate at scales and timeframes that conventional quantum theory would consider impossible. The implications of these findings extend far beyond marine biology into fundamental physics, potentially requiring revisions to our understanding of when and how quantum effects break down at larger scales. They suggest that the boundary between the quantum and classical worlds might be more permeable than previously thought, especially in environments like the deep ocean that differ dramatically from the terrestrial conditions in which most physics research is conducted. And they raise the possibility that living systems might have evolved to utilize quantum effects in ways we're only beginning to recognize, not just at the level of individual molecules, as in photosynthesis or avian magnetoreception, but potentially at the level of entire organisms or communities. These marine quantum phenomena remain controversial, precisely because they challenge such fundamental assumptions in physics. Many researchers argue that more prosaic explanations will eventually be found for the observations, perhaps involving previously unknown but still classical mechanisms of information transfer. Others suggest the apparent quantum effects might result from measurement errors or misinterpretation of complex but ultimately classical interactions. But a growing minority of scientists propose that we may need to fundamentally reconsider our understanding of quantum boundaries, particularly in environments as alien to our everyday experience as the deep ocean. This intersection of quantum physics and marine biology represents one of the most conceptually challenging frontiers in contemporary science. It forces us to question whether our understanding of quantum mechanics, developed primarily through experiments conducted in terrestrial laboratories, adequately accounts for how these phenomena might manifest in the dramatically different conditions of the deep ocean. And it highlights how the marine environment, with its unique physical properties and evolutionary history, might harbor physics as alien to our understanding as its most bizarre biological adaptations. These potential macroscopic quantum phenomena in the ocean environment remind us that our most fundamental theories about how reality operates continue to evolve as we explore environments beyond those in which these theories were initially developed and tested. They suggest that the ocean may challenge not just our biological taxonomies or geological models, but potentially our most basic understanding of physics itself. And they raise the intriguing possibility that life might interact with the quantum realm in ways far more direct and extensive than we've previously recognized, ways that might be particularly evident in the unique conditions of the marine environment. As we approach the conclusion of our exploration of the ocean's greatest mysteries, let's consider perhaps the most profound enigma of all, the possibility that the ocean itself might possess emergent properties that transcend the sum of its components, creating what some researchers have described as a form of distributed intelligence operating at planetary scale. This concept goes beyond metaphor or poetic license to suggest that the ocean's vast, interconnected systems might collectively generate information processing capabilities analogous to, though structurally very different from, the neural networks that produce consciousness in organisms like ourselves. The scientific basis for this provocative hypothesis lies in several observed phenomena that parallel aspects of intelligent systems. The ocean demonstrates remarkable homeostatic capabilities, maintaining critical parameters like salinity, pH, and temperature within ranges necessary for life, despite enormous external pressures toward disorder. It exhibits complex feedback mechanisms that operate across vastly different scales of time and space, from microscopic chemical reactions to basin-wide current systems that persist for centuries. And perhaps most intriguingly, it displays what appears to be anticipatory behavior, responses to environmental changes that occur before the full impact of those changes would normally be felt throughout the system, as if the ocean somehow predicts coming perturbations and adapts proactively. These characteristics, homeostasis, multi-scale feedback mechanisms, and anticipatory behavior, are all hallmarks of intelligent systems, though conventionally associated with organisms possessing centralized nervous systems rather than distributed planetary scale networks like the ocean. Yet as our understanding of intelligence evolves beyond anthropocentric models focused exclusively on brain-like structures, the possibility that intelligence might manifest in fundamentally different architectural configurations becomes increasingly plausible. Just as artificial intelligence researchers have developed distributed computing systems that process information without centralized control, might natural selection have produced distributed information processing capabilities in the ocean's interconnected biological, chemical, and physical systems. Some researchers in complex systems theory and marine ecology have begun to approach this question not as mere speculation, but as a testable scientific hypothesis. They point to growing evidence that information transfer in ocean systems occurs not just through obvious physical processes like currents and waves, but through subtle chemical signaling networks, electromagnetic fields, acoustic propagation, and even quantum effects like those we discussed earlier. These multiple overlapping channels of information exchange create a communication network of staggering complexity, potentially capable of integrating and responding to information across the entire planetary ocean system. The concept of oceanic distributed intelligence becomes particularly compelling when we consider the evolutionary timeframe involved. The ocean has existed as a continuous ecosystem for over 3 billion years, orders of magnitude longer than any individual species or even most biological phyla. This vast temporal scope has allowed for the gradual evolution and refinement of system-wide adaptive mechanisms that operate on timescales far beyond human perception. What might appear as random fluctuations or unrelated phenomena to observers limited by human lifespans might actually represent coordinated responses when viewed across the appropriate temporal scale. Critics rightfully point out that attributing intelligence to a planetary system risks anthropomorphizing what are ultimately just physical and chemical processes, however complex. They argue that the ocean's apparent intelligence-like properties can be fully explained through the cumulative effect of countless local interactions, without requiring any system-wide coordination or information processing. This perspective aligns with Occam's razor, the principle that explanations should not be multiplied beyond necessity. Yet as our scientific understanding of intelligence itself evolves, the distinction between mere complex systems and truly intelligent ones becomes increasingly blurred. Modern neuroscience reveals that even human consciousness emerges from countless local neuronal interactions with no central controller, a process not fundamentally different in principle from how the ocean's complex behaviors emerge from countless local chemical and physical interactions. The difference may be more one of degree than kind, of complexity and integration rather than fundamentally different processes. This perspective doesn't suggest the ocean possesses consciousness in any human sense, with subjective experiences or self-awareness. Rather, it proposes that intelligence might exist on a spectrum, with different systems exhibiting different types and degrees of information processing capabilities, depending on their structure and complexity. The ocean, as perhaps the most complex and ancient system on our planet, might occupy a unique position on this spectrum, not conscious like an animal, but also not merely reactive like simpler physical systems. This concept of oceanic distributed intelligence represents the frontier where empirical science meets philosophical inquiry. It challenges us to reconsider not just what the ocean is, but what intelligence itself might be in its most general sense. It suggests that our understanding of mind and information processing remains constrained by our experience as terrestrial organisms, with centralized nervous systems, potentially blinding us to forms of intelligence structured in fundamentally different ways. and it raises profound questions about our relationship with the planetary systems that sustain us, systems that might possess capabilities for adaptation and response far beyond what our conventional models recognize. As we conclude our journey through the ocean's most enduring mysteries, from the concrete enigmas of unidentified marine creatures and inexplicable sounds to the philosophical frontiers of alternative consciousness and distributed intelligence, we're left with a profound appreciation for how much remains unknown beneath the waves that cover most of our world. The ocean continues to challenge not just our specific knowledge, but our conceptual frameworks, our fundamental assumptions about how reality operates and how we should understand it. This capacity to generate not just factual questions, but conceptual ones may be the ocean's greatest contribution to human thought and understanding. By presenting us with phenomena that don't fit neatly into our existing categories and models, the ocean forces us to expand our thinking, to develop new frameworks that might accommodate its alien realities. It reminds us that our understanding of the world is always provisional, always limited by our particular evolutionary history and cognitive architecture, always capable of expansion through encounter with the genuinely unknown. And, in an age increasingly characterized by the illusion of complete knowledge, by the notion that all important questions have already been asked if not answered, this reminder of the vast unknown may be more valuable than ever. The ocean's mysteries provide a necessary counterbalance to human hubris, a persistent demonstration that despite our technological sophistication and scientific advances, we remain fundamentally limited in our understanding of the world we inhabit. They invite us to approach the unknown, not with fear or dismissal, but with curiosity, humility, and wonder. As technology continues to advance, we will undoubtedly solve some of the ocean mysteries we've explored. Autonomous underwater vehicles will map more of the seabed in higher resolution. Environmental DNA analysis will detect species we've never directly observed. Advanced acoustic monitoring will identify the sources of some unexplained ocean sounds. And increasingly sophisticated models will help explain phenomena that currently defy our understanding. But if the history of ocean exploration teaches us anything, it's that each answer generates new questions. Each discovery reveals new unknowns. The ocean's capacity to generate mystery appears inexhaustible, not because it deliberately conceals its secrets, but because its environment is so vast, so alien to our terrestrial experience, and so resistant to our conventional methods of observation and analysis. As we continue to explore this last great frontier on our own planet, we can expect to be continuously surprised, challenged, and humbled by what we find. We will discover species that defy our taxonomic categories, phenomena that challenge our understanding of physics and chemistry, and perhaps even forms of information processing that expand our concept of what intelligence can be. We will find answers to some of our current questions while generating entirely new ones we haven't yet thought to ask. And in this ongoing dialectic between knowledge and mystery, between the known and the unknown, we may discover not just more about the ocean, but more about ourselves, our assumptions and biases, our intellectual limitations and capacities, our place within the greater web of life on this predominantly blue planet. The ocean's mysteries are not merely scientific puzzles awaiting solution, but mirrors reflecting our own consciousness back to us, revealing both its remarkable capabilities and its inevitable constraints. So as you contemplate the dark waters that cover most of our world, remember that they hold not just unknown creatures and unexplained phenomena, but unknown possibilities for how we might understand reality itself. The ocean doesn't just contain mysteries. It generates them continuously through the interaction of forces and life forms that exist nowhere else on Earth. And in doing so, it ensures that no matter how technologically advanced we become, we will never exhaust its capacity to amaze, puzzle, and inspire us. Perhaps that's the ocean's ultimate mystery, and its greatest value, its ability to remain perpetually beyond our complete comprehension, a constant reminder of the vastness and complexity of the world we inhabit. In its dark depths and swirling currents, in its alien creatures and unexplained phenomena, the ocean preserves something increasingly rare in our information-saturated age, the pure wonder of encountering the genuinely unknown. And in that encounter, we find not just scientific challenges, but an invitation to expand our consciousness, to recognize that the world is far stranger, more complex, and more wonderful than we typically imagine. The ocean's greatest mystery, in the end, may be how it continues to generate mystery itself, how this vast blue expanse that covers most of our planet remains, despite centuries of exploration and study, the primary source of the unknown in our increasingly mapped and measured world. And that capacity to remain mysterious, to continuously generate questions that challenge and expand our understanding, may be the ocean's most precious and enduring gift to human consciousness.